Hi, welcome to the Git and GitHub course. So I'd like to thank you for taking this course. It's really an honor to be teaching you, and we're going to try and go over everything there is to do with Git and GitHub. So we're going to start with a little course introduction. So we're just going to go through the syllabus, what's in it, and I'm going to be giving you a step-by-step list of what we're going to be doing in the course. So let's get started. In the first section, which is this section, we're going to be introducing Git. So we're going to talk a little bit about the theory behind Git. Now, this doesn't mean the workflow or the concepts. We're just going to talk about a little bit about what Git is and where it came from, and just some of the general concepts about version control, source control. So on top of that, we're going to install Git and all of the other features we are going to need in the course. So, our terminal, our bash terminal for Windows, you don't need to worry about what that is now. We're just going to do that in this section. So I'm going to be going through and installing all these, teaching you how to install them, because there are a few features that may confuse you. So I'm going to go through and give you a full rundown of what we need to do to install everything the correct way. So the second section is solely focused on the terminal. So you probably, if you're new to development or programming, you probably have no idea what a terminal is. So we're going to go over all of that in this section. Now, this is because the terminal is not just some section that I added in there for fun. It's because in order to use Git, you need to be able to use the terminal properly. Now, it's not like you need to know all the commands and you need to be an expert in it, but you just need to know how to navigate around, know your way, just know some of the general features of it and be comfortable in that environment. It's not like any other environment that you've probably been in, such as the File Explorer or maybe even the internet or websites. It's quite bare bones, and it's just the purest way of interacting with your machine. So we're going to learn how to interact with that, learn the environment, and move around with some basic commands. So we're going to do that in that section. So the third section is where we start to get into the deeper parts of Git. So after the whole overview in the first section, or this section, we're going to start working at the workflow behind Git. So we're going to learn a little bit about how Git processes things. So, you go from making some changes to a file to putting it in the repository. Don't worry about what all that means. We'll talk about it later. So we learn about all of the flowcharts and workflow behind Git. On top of that, I'm going to teach you some basic commands so that you know how to do all of this yourself. But it's not really about the commands, it's more about the concepts, because Git is quite a complex topic if taught wrong or if interpreted wrong. So I'm going to try and make sure to go through as smooth as possible and explain it all to you so that you understand the basics of the Git workflow. So after we learn the basics of Git and basically the core of it, we're going to work into another integral part of version control in Git, and this is called branches. So we're going to focus completely on branches because it's such a big topic and it's kind of its own thing, and you can't really group it together with all the other stuff. So we're going to have a whole section just completely dedicated to branches. We're going to talk about how they work, what they are, and just how to work with them in the terminal. So we're going to do that in section 4. So in section 5, we're pretty much almost finished with Git. We still have a few more things to do, but we need GitHub for this. So we're going to be learning what GitHub is. So I'm not really going to talk about it now. If you know what GitHub is, and I'm sure a lot of developers do, then just go ahead, speed along if you want, even skip the entire section. But we're going to go through and I'm going to talk about what GitHub is. Now, a lot of people think that GitHub and Git are the same thing, and they're completely different. We're going to talk about them in the next video, so we're going to talk about the differences. But for now, in section 5, we're just going to run through GitHub. We're going to create an account, and then we're going to go and look at some repositories and just check everything out, see how GitHub really works, because it's such an important part in developer communities. So we're going to go through GitHub in detail and see how all that works. So in the 6th section, we're going to be moving on to finally connecting our Git and GitHub knowledge together. So this is what I was saying, is we didn't learn everything about Git. This is where the really important part comes in, because sure, you can use Git on your own machine, but without somewhere to put it and make it public and allow, make it open source, for example, Git is kind of useless. And of course there are still uses, but adding GitHub or some other shared server makes it so much more interesting, and it just adds a whole new world of opportunities. So we're going to learn how to, for example, take our Git directory or repository and put it on GitHub. We're going to learn about the push and pull system. You can see in that picture here how it works. Of course, you can probably take a little bit from that, but I'm going to explain it in much more detail in that section. And we're going to learn how to sort of interact and, change between the two interchangeably. So we're going to do that in that section. So in the 7th section, we're going to be learning Git GUI, so graphical user interface. So this is kind of a bonus section. I didn't actually talk about it that much and I wasn't considering it, but I felt that it was a good way to allow more ways to use Git, to show that Git isn't just some terminal commands that you can do. It's a whole thing in itself. So basically, I'm not going to go through it in that much detail, but instead of using a terminal, you can actually use a program to do all of the cool features that Git has. So adding files, committing, pushing it to a repository, doing all of that through a program. We're going to use a really nice program. It's called SourceTree. So we're going to use that. And basically, it just allows you to do everything in a graphical user interface. So you do have to watch all of the videos before that, and I would recommend it, because without it you don't have really much of a basis or much knowledge about Git. And we go through things quite quick in SourceTree. I just teach you how to use the software. I don't teach you about all of the theory, because of course we already did that. So I recommend you go through all of the terminal video first. Even if it's a little bit confusing and you want to use SourceTree, it's good to have 2 mediums under your belt in case you have to switch between environments. So in this video, I'm going to be going over what Git is. So I'm going to be talking about the concept behind it. Now I'm not going to necessarily go into the the details and the workflow and everything. We're going to leave that for later when we get some experience with all the other requirements that we need, such as the terminal. But for now, I just want to give you a general idea of what Git is before we start using it, so that you just have some sort of conceptual understanding of what it is. So let's get started. So before we talk about Git, I need to talk about source control, because Git isn't just some independent software. It's based on a larger group of software called source control or version control. So basically what it is, it's some system or some software that allows you to track changes or track your file progress in a project or directory over time. So it allows you to distribute your changes over a timeline in chronological order. So you can see here there is a little picture that shows you how this looks like. Obviously this is an oversimplified representation of what source control looks like, but you can see there's multiple nodes and they're branching out, and it's just in a sort of timeline fashion. Now, not all source control is like this with multiple branches and all this complex, but it's just a way to allow you to take snapshots of your project over time. So for example, if you want to go back in time and view your project, you can. So it's not just like you have one project, you work on it, and when you're finished, you can only view the finished product. What Git and what source control allows you to do is view how your project has progressed over time. So it's really useful. So it's not just viewing your project. There's a lot of things that source control allow you to do that you might not necessarily be able to do without it. So firstly, and pretty obviously, which I explained in the previous section, was being able to distribute your file changes over time. So put it in a timeline and just extend it out so that you can see your progress over the certain time period from when you started the project to when you finished. On top of that, there's a few other benefits to using source control. One of them is to prevent against data loss or damage. Now, you probably have no idea how this works, but pretty much, let's just say that you're working on a project. For example, some big scalable system, enterprise, let's just say you're working for a company. Now, let's say you mess up big time and you make something or you do something in the code that you break and you don't know how to fix it. It's irreversible. Now, without source control, this would be an absolute disaster, because if you don't have backups, you're pretty much in the ground, because if you don't have backups, again, you can't recover your code, and if it's irreversible, you're going to have to start from the ground. But that's not the point. Most companies would have backups today, but what source control allows you to do is if you mess up, you can easily go back in time to the latest working copy that you saved and start over. So you can keep doing this over and over again as many times as you want. So this is a really big benefit to source control and is why a lot of people use it. So it's really great. So the second one here is manage complex project structures. So like I was saying before, it just helps to deal with bigger projects. So one of the most notable examples is Linux. So if you go on GitHub and you search for Linux, what you're actually going to find is a repository for Linux, and it's a massive project. Linux is one of the biggest projects on GitHub today. So it has hundreds of thousands of commits from contributors all over the world because it's open source. But the thing is, without it, imagine how an operating system or a browser or anything that is a huge project would look like. It's really hard to manage your structures if you just have one snapshot, just one piece. Now, sure, you can go through and make updates and copies, but with source control, it allows you to branch out and experiment and have different sections of your code that you can manage independently. So if this doesn't make much sense to you, don't worry about it. It's not that important for you unless you're working as a senior engineer for example, Oracle. So don't worry about that too much, but it just allows you to manage complex structures very easily. So that's pretty much it for what you can do with source control. But why don't we actually talk about Git here? You can actually see the logo right there. So Git, now that I've explained source control, I don't really need to explain Git because Git is just a source control software. And it was created by the same person who created Linux, and it was actually created to manage Linux. So it's just a regular old source control software, and it's similar to others. And I'm going to just go back a slide. One of the most notable or other very popular ones are Mercurial. That's a very popular source control software that is used as an alternative to Git. And there's a few others here, but Mercurial is one of the most popular. But there's a few advantages to using Git over such as any one of these other source control softwares. The first is it's the most popular source control software in the world. By far, it is the most popular and it has the most support. So here it has a lot of documentation, support, courses, just like this one, videos. You can find them all over the place because Git is the industry standard for source control. On top of that, it has integration with many applications. So I'll give you one example, SourceTree, the GUI that we're going to be using later. But that's a little bit pretty obvious because it's a source control GUI. It needs to be integrated. So I'll give you a better example. There is a hosting, it's called Heroku. So it allows you to host large Node.js apps. You don't need to know what that means if you don't, but pretty much what you have to do is in order to push something or, take your website live or take your application live, you need to have a Git repository on GitHub or wherever else. But you need to have a repository that you can push into Heroku so that it can host on its platform. So that's one use, and you can see that GitHub, Git, and all of this source control is very widely used, and it has a lot of integration. So a lot of different software requires these applications to, work with their platform. So I'm just gonna, have a quick summary before we go off. So Git is just a source or version control software, just one of many out there. But we're using it because it's the most popular and most supported source control software in the world, as well as having lots of integration. So I hope this video gave you a little bit of an insight onto what source control is, what Git is, and why, most importantly, we're using Git. Because I could do a course on any other source control. It's almost all the same with some variation in syntax. I could have done almost any other one, but I'm using it because it's the most popular and you can take away the most value from learning this skill. All right, let's move on. In this video, I'm going to be talking about the differences between Git and GitHub. So I'm going to be talking about what GitHub is, and I'm not going to go into detail because we have a whole section on that and I want to save it for there, but I'm just going to go over an overview about what it does, what GitHub is, so that you can start to identify some of the differences between Git and GitHub. So first of all, let's talk about what GitHub is. So pretty much GitHub allows you to store your Git repositories. Just think of repositories as folders for now. We're not going to talk about them yet. We're going to talk about them when we start using Git in depth. But just think of them as folders where you store your timeline or your Git timeline, your source control. So GitHub basically allows you or gives you some server space to store your repositories remotely. So you can see I put a little comment there. It's in the name. It's called GitHub, hub for, Git pretty much. I'm sure you understand. So you can interact with this through your local machine through the push-pull system. I'm going to be referring to this a lot until we get to it, but pretty much just think of it as a way to get information from your GitHub repository and give information to your GitHub repository. So we're just going to use this push and pull system to interact with it. So GitHub is not just used to store it somewhere and get rid of it. It's mainly used to open up a lot of new opportunities for Git, and it just adds a lot of new functionality. So for example, you can actually add collaborators. So you can work on the project with your team members, for example, if you're working in a company, or let's just say you're building some small, maybe fun application with your friends. You can put it on GitHub, and then all 3, 4, 5 of you, however many of you, you can all interact with it at the same time. Now, this is based on collaborators, and we're going to talk about, collaborations, GitHub, all of that in a later section. So you don't need to worry about how to do this yet. We're just going to talk about what GitHub does. So this is what you need to take away. GitHub stores your repositories on their servers, and it just gives you a whole lot of new functionality on top of Git. So let's talk about the differences between Git and GitHub. Now, if you haven't already identified them, I'm going to give them to you for you. So here you go. So Git is the source control software that allows you to create these snapshots and push them, and it gives you all of the functionality, the backbone, kind of the skeleton of source control. Whereas GitHub works with Git to add more functionality and, for example, store these Git repositories on their servers. So GitHub kind of not only builds off of Git, but it gives you a platform to use Git. So it's kind of like SourceTree in a way, in that it allows you to interact with Git in a more user-friendly fashion, but it's not just about that. It gives you a way to work with Git under a new perspective, and it gives you a whole lot of new functionality. So let's just think of it this way. Git is the bones and flesh of source control. You can see I put that comment there. It's the bare bone, it's what builds source control software, and then GitHub just works with Git to give you a new perspective and new opportunities on the source control software. So that's what you need to take away. Alright, so now that we've gone over GitHub and Git and how all of the differences work, we're going to start moving on and actually setting up our software. And now that you have a full understanding of some of the background theory behind Git, GitHub, and the differences between them. Alright, let's move on. Now that you have an understanding of Git, we're going to move on to install all of the required software that we need. Now, I have a few extra software, but I'm not going to tell you about those. You can go and search about them in your own time because we're not going to really use them in this course. But I'm going to talk to you about the main stuff that we need, the main software, the main systems. So these are the main systems that I'm going to show you right now. First one is Git. Now, we're not going to use Git bash. You can if you want to. All we need is a bash shell. We're going to talk about shells and all of that in the terminal section. But you just need kind of a shell or command prompt like this. It's not really a command prompt, but whatever you want to call it. So we need something like this. Now, I'm not going to use this one supplied by Git. So when we install Git, we get that. What I'm going to use is the Ubuntu shell for Windows, or the Unix shell for Windows. So I'm going to teach you how to do that in this video. I've just done a little bit of formatting on this. So we need something like this. You can see if I open this one, I'll show you. They look pretty much exactly the same, just a few username changes that I've made myself, but they look almost exactly the same. So we are going to be going forward, and I'm going to teach you how to install this terminal and get used to it. All right, let's get started. So the first thing we want to do is learn how to install Git. So let's go ahead and do that now. First thing I want to do is go ahead and open up Google Chrome or whatever your browser is. And the first thing you want to do is search for Git. So it's going to come up with this. And what you're going to do is just go here. And it should give you this website. I will link the website in the content or the lectures. So I'm going to link it there if you don't want to Google search it. So, and it will take you to this page. So what you want to do is go ahead and go to downloads right there. And now you can choose your operating system. If you're using Linux or Unix, you can go ahead and do that if you're using OS X or Windows, which is the one I'm using. So I'm just going to go into my downloads and open up the Git installer right here. So I'm just going to open that so I can show you how you install it. So you're going to accept any changes that you want to make. And there you go, it's going to give you the setup. So I'm going to go next and I'm going to run you through this so you know what to do. So right here under additional icons, if you click on the desktop, it's just going to add a desktop icon for the Git Bash terminal. So under Windows Explorer integration, this is just your terminals, your GUIs. We talked about Git GUIs here, but we're not going to use the default Git GUI. It's not really user friendly. We're going to use SourceTree. Talked about that before, but you're just going to install it if you want. You don't need to. You can install Git Bash if you don't want to use the Ubuntu terminal. If you have Windows, if you don't want to use that, you can always install Git Bash. And we'll talk about some other alternatives for Windows users. If you're on Mac or Linux, of course, you can just open up Terminal. I'm sure you all know what that is. If you don't, just search Terminal on Mac, Linux. It's just Command T or Control T, whichever one you're using. So we're going to go ahead and install that. And you're just going to keep all of these on. Of course, keep these last 5 the default. So let's go next. Now you can select the default editor. So Vim is quite an advanced editor. So we're not going to really use the editor for Git, but if you want, you can go ahead and select Notepad++. You do have to have it installed. If you installed it during while the installer was open for Git, just like I did, you're going to have to reopen the installer for Git in order for it to recognize that Notepad++ has been installed. So you can go ahead and do that. If you have Visual Studio, you can use that. I would recommend just going with Notepad++. We're not going to use the editor, but if you ever want to go forward and learn more about this, you can always do that. So I'm just going to click Next. And now here is what I was talking about, some of the parts that you may get confused on. So first of all, it says use Git from Git Bash only. So this will only take Git commands or only accept them from the Git Bash terminal. We don't want that because we want to have a little bit more variety. So when you say use Git from the Windows command prompt, it doesn't mean just from the Windows command prompt. It means from all of the Bash terminals, other terminals, including the Windows command prompt and some other terminals or shells, such as Windows PowerShell. If you look at it right here, I really like this terminal for Windows. It doesn't have all of the core Unix commands and terminal commands, but I really enjoy it. It's really clean for Windows users. We're going to go over that later, but for now you just want to select this. And the reason we're not selecting this is because it will override some Windows tools and functions. So we don't want to do that. We want to leave that as it is. We don't want to touch that. So we're going to use Git from the Windows CMD command prompt. And now here is for choosing HTTPS transport backend. So this is pretty much just for authentication, connection to remote servers such as GitHub. We're going to select the OpenSSL library. And now here is something called, checkout window style, commit Unix style line ending. So pretty much this is just a little bit of formatting, conversions between characters and things like that. So we're just going to go with the default here. Checkout window style, commit Unix style, line endings. This is not really important. It's more for advanced users. So we're just going to leave it like this. And here, configuring the terminal emulator to use with Git Bash. Pretty much what this is going to do is change how Git Bash looks. So MINTTY, this is what defines what Git Bash looks like. It makes it look more like a Unix terminal. Whereas if you select this one, Git Bash, when you open it, will just look like a command prompt. It won't really look anything different. So you're going to select this. We're going to go next. There's a few other things here. Git credential manager is more for teams and companies, so you don't really need to worry about that unless you're working in a team or a company. Enable file system caching. We're going to leave that on for performance enhancement. And when you're done with that, you can click install. So we're not going to install it obviously because I already have it installed. But if you want to test if your Git is working, all you have to do is open up your Git bash terminal. Even having a Git bash terminal is a good sign. You can also even open up any other terminal and you can just go git -- version. And that will give you the version. And if you type this in and it works, don't worry about, this might look scary to you, but don't worry about it. But if it shows that something returns and it's not Git is an unknown command or cmd lit or something like that, then you know that Git has been installed correctly. Okay, so now that we've installed Git bash, why don't I go ahead and show you how to work and install the Ubuntu terminal, so the one for Windows. Now, if you're using something other than Windows, maybe Mac or Linux, you don't really need to worry about this step because you have a native terminal already installed into your operating system. But if you don't, I'm going to show you how to go through and get this. So you can actually do this by default because what happened is Windows didn't have this native support before. But what happened is Microsoft realized that there's a big demand for developers, developers working with Windows, so they added some Linux features. But it's disabled by default, so you have to go and enable it. So what you want to do is go to your control panel. Then you're going to go to Programs and then turn Windows features on or off. Now it'll bring up this little wizard window here. You're going to scroll all the way to the bottom and look for Windows Subsystem for Linux. You're going to tick this and make sure it's on. So just a warning, when you do this, you will have to restart your computer. So that's just a warning. But in order to install it, you need to restart your computer. So just go ahead and do that after the video has ended, or whenever you want. But in order for this to work, you need to restart your computer. All right, let's go ahead and finish the rest of this. So what you want to do is go to the Microsoft Store. And from here, we're going to download the Unix shell, Unix terminal. So you're going to go into search and you're going to search for Ubuntu. And you're just going to hit search. And, it brings up a little ad here, it shows install and run Linux distribution. So you can see that Windows and Microsoft is really trying to make an effort to advertise these Linux distributions. So you can see a bunch here. There's Debian, Kali. You don't have to know what these means if you're not, into IT and networking. You shouldn't really know what that is. But what you're going to do is just install Ubuntu. So you're just going to download that. And once you're done, you can just go into your search bar and search Ubuntu. And once you open that, it'll open up your terminal. So I already have mine installed, but for you, it'll show some installers. So it's going to say maybe something along the lines of, it's installing, please wait a few minutes. Or if you get a message saying some other error message, such as, Windows Subsystem for Linux is not enabled or anything like that, then just go back in time and retrace the steps. But if you're still having problems, ask a question in the Q&As. I'm always available to reply. Might message me personally if I can't reply or if you don't get a reply, but that's besides the point. So if you have problems, just ask questions. But after that, pretty much your bash terminal, your bash shell will be installed. So from here we can do whatever we want. I'm just going to write a few commands. You're going to learn most of these in the future videos in section 2. So we're going to learn how to do all of this later. So I hope you get a little bit excited, making folders, things like this. We're going to do that in the future section. So there we go. We have all of our software installed, and so let's move on to starting to get a little bit of knowledge about the terminal so we can start actually using Git in our software. All right, let's move on. So we made it through the sort of boring part and we did all the introductions and all the boring stuff in theory, but now we're going to start actually getting hands-on and working with some of the features that we're going to use throughout the course. So for now, I just want to give a really quick introduction I want to whiz through this really quickly so you just know what to expect in the next section. So this section is going to be totally focused on the terminal. We're going to learn everything to do with a terminal. We're going to learn what a terminal is, how it works, just everything to do with it. So we're going to learn different commands and, the different parts of the terminal, how it works. And like I said, we're just going to cover everything so that we get really comfortable with this environment. So firstly, we're going to go over a sort of introduction. So we're going to look hands-on on the terminal instead of going through a PowerPoint, because I feel we've done enough PowerPoints already. And we're just going to look at the different parts of the terminal. So, the username, the computer or the machine name, the input-output cycle, all of these different things. We're going to learn what a shell is, terminal is. We're going to talk about all of this theory while actually doing, so it's not just all boring stuff. So then after we cover all of the theory, we're going to go to console commands. So this is the fun part where you get to learn all of this interesting stuff. Now, don't worry, we're not going to do anything complex like this. We're not going to learn sudo commands or installs, packages. We're just going to learn some basic navigation. So creating and deleting folders, moving between folders, things like that, because we don't really need this advanced console shell scripting for the course. We're not going to cover that because, again, this is a Git course. It's not a terminal course or a Linux course. So we're just going to dive straight into Git. So all we need to do is learn some basic navigation commands so that just to get more comfortable with the environment. So let's get started. So in this video, I'm going to be introducing the terminal. So now that we've installed all of our required programs and software and systems, we're now going to move in to working with the terminal. So firstly, what is the terminal? Well, pretty much a terminal is a way to interact with your operating system directly. Now, of course, there are many ways to interact with your operating system. So, for example, if I just open up the File Explorer here, you can see I can go through my desktop, my folders, I can interact with it. On top of that, this desktop is a way to interact with your operating system. It was built into Windows to give a more user-friendly experience. But all of this is just solely built off of the terminal. So if I'm going to go ahead and open up my command prompt here, which is the Windows terminal, and you can see it's quite large. I'm trying to make the font big so that everyone can see it. But all of this is built off of the command prompt, this terminal and the commands that come with it. And basically, this goes the same to Git and SourceTree. So I'm going to give you a little analogy. So Git gives you all of the commands, the backbone, all of that. But then SourceTree, which is our GUI that we're going to be using later, allows you to have a more user-friendly experience when using Git instead of typing into a black and white terminal. So that's pretty much what an operating system does. It takes these bare-bone commands that you do through a shell or a terminal, and it allows you to do all of these things, but in a more user-friendly fashion. That's pretty much the goal of an operating system, such as Windows, Mac, or Linux. The goal is to make a more user-friendly experience and hiding all of the complicated terminal stuff that goes on behind the scenes. But even with this, there's still a lot of stuff that you can do in the terminal that you cannot do with these GUIs. And the workflow is a lot easier, especially for developers, which is why we're using it. On top of having a lot of different systems, such as Git, built through the terminal. So I'm just going to open up my Ubuntu bash shell here, and we're going to explain the difference between this and a few others. So I'm going to go ahead and open up this and our command prompt. So I'm going to go Windows Run, and I'm just going to type CMD and click OK. And that's going to open up our CMD, or our Windows shell. And if you're wondering, a shell and a terminal are almost the exact same thing. A shell is just a way to interact with your operating system, which is what a terminal is. So let's go ahead and look at some of the differences. So you can see, first of all, the font is a little bit big. We're not going to worry about that for now. But pretty much what this allows you to do is here you're directly in your Windows machine. You can see we're in our C drive /users/JAD. And we're going to explain file systems later, but we're in our Windows machine. Whereas here, this is more of a subsystem. So we're actually inside Ubuntu when we're using this terminal. And sure, we can't interact with it, such as the way we interact with Windows, but the reason that we're in Ubuntu and not our Windows directory is because, remember in the installation video when we went through and we ticked the Windows subsystem for Linux and all of that? Well, that was actually Windows or Microsoft taking the initiative and actually enabling you to create a subsystem of Linux or Ubuntu inside your Windows machine. So we created this Linux subsystem in which you can now install these Linux distributions. So for example, Ubuntu or any other distribution you want to use. And from there, we're pretty much interacting with the Ubuntu operating system. Now, of course, we don't have any GUIs, but we have this terminal which allows us to interact with it. And if I actually show you cd ... now you don't need to know these commands for now, but if I actually list all of the files, you can see we have none of this stuff in our home drive for Windows, because if I go to our command prompt now and I actually type ls, it won't work because it's not recognized as a command in the command prompt. So you can see that these are very different shells. The Windows shell has a completely different set of commands than a regular bash shell, which is, by the way, the most commonly used one for developers. Not many people use the command prompt, and the bash shell is kind of considered the universal terminal to use. So that's why we're going to be using this one. Now, I'm just going to teach you how to access your Windows drive right here. So if you do cd ... twice, it's going to bring you up to your root. If you want to get into your Windows drive, all you need to do is cd into mount. Now, you don't need to know what this does or what cd does, but basically just think of this as moving between directories. So from here, you can now cd into your Windows drive. So you can see it's mount/c, which is the C drive, as you can see here. And now from here, you can go pretty much wherever you want. We have our program files, but if you want to get to your user, so your desktop, your files, you have to cd into users. And then from there, you can cd into your user. And then you can do whatever you want from there. So I have my desktop, my documents, all of that here. So you can see that these do have some slight differences between the Windows shell and the Ubuntu bash terminal. But again, if you're on Mac or Linux, you don't really have to go through any of this because you already have a native shell installed. But for Windows users, this is the best way to get a native shell without using our Git bash. So there we go. Now that we've explained some of the differences between a terminal and what it is, let's move on to some other things about the terminal. So I'm just going to talk a little bit about file structure. So if we go into our file explorer, and let's say I just want to open some random text document. So what I would do, let's say I go into my desktop, I open my folders, I open my projects, all of that, and you can see I have a bunch of stuff here. This is just a dummy project, don't worry what these names mean or anything. But let's just say I want to go here and there's some random text file that I want to use. So I'm going to go and create a new text file, and I'm just going to call this file.txt. Sorry. There we go. So I've created a text file. And we did all of that through the GUI. But how do we do this through the terminal? And more importantly, what does it look like? Because clearly, it's not just going to list all of it in a neat, nice order like this, with icons and everything. So this is how it works. Now, if I actually click here, you can see that it brings up this path. So without it, it says, this PC, and then to desktop, to folders, to project. But if you click on it, it gives you this path. So if you already don't know what a path is, or if you're just starting out, basically what it allows you to do is specify what folder you're in. So it allows you to classify everything. So we start with the top level, which is the C drive. Then we go into our users, then your specified user, then your desktop, then folders, then projects. So it's kind of in a classification kind of order. So there's a top level set, which is your C drive, and then inside that there's users, then your user, then desktops, and so on. So we can actually interact with this directly through the terminal. Now I'm just going to make this full screen, and I'm going to clear it because there's a lot of ugly bars in the screen. But you can see here that there is our path right there. That is where we currently are. And this path specifies where we can go. So, and what we can do with the folder. So in the future, when we start learning the basics of Git, you can use a command called git init, which allows you to initialize Git in that folder or that directory. So you can do all sorts of things, but basically the path allows you to see what folder you're in. And depending on what folder you're in, you can run certain commands, executions, functions, all sorts of things like that. So now that we're done with paths, let's explain some of the different parts of the terminal. So you can see right here, I have my user, and you can see if you're on any machine, you can share users. You can have multiple users on a single machine. So you have your username @ and then the name of the machine. Usually it's your model number or something similar to that. So there you go. That's going to tell you the name of your machine, and that's going to give you your username. And then after the colon, it's going to be your path. But by default, I'm just going to close off the terminal. I'm going to close that. Now, if I'm going to open my Ubuntu shell here, so you can see what it's going to look like for you from the start. You're going to see this, this little character here. So what does that actually signify? Well, this signifies your home directory. So pretty much all terminals have a home directory that you can edit through editing files in some text editor or some IDE. We're not going to go into editing it, but pretty much that symbol signifies your default directory. So I'm just going to, cd out of here. And like I said, you don't need to know any of these commands. But what I'm trying to do is just get away from the directory. So let's say I go really, really far and I want to get back to the start, which is our starting directory for Ubuntu. So I'm in my C drive right now, but I don't want to go back and retrace all of my steps. I don't want to do cd ... all of that to go back. What I want to do is just go straight to it. There's actually a very simple command to go to your default directory. It's just cd and then that character. It's right above tab for Windows users. So there you go. That character signifies your home directory instead of having to type the whole thing out or moving backwards or all sorts of things like that. So just know that that character signifies your home path or your home directory. And when you type that in, there you go, takes you back there. So that's pretty much it for the paths and terminal. And now that we've covered all of the parts, we're going to move on to some of the more interesting stuff. So we're going to go through, we're going to learn some of the commands. And I'm sure you've already kind of picked up some of the commands here. It's quite easy to pick up, but what we're going to do, go through, learn the commands, and just get really familiar with the terminal before we move on to Git. Now, if you're already experienced with the terminal, you do not have to go and take this section. It's for users who are just beginning with maybe their development careers or something like that. So if you're experienced with a terminal, feel free to skip this section. Most of this stuff you probably already know, but if you have no idea what a terminal is, then you should probably stick along and learn some of these commands. All right, let's move on. So now that you are familiar with what the terminal is, we're going to start moving forward and learning some commands. And the first command that we're going to learn, and probably the most important, is the cd or change directory command. So I have my Unix shell, my Ubuntu terminal open. You can use whatever terminal you want as long as it's not command prompt or PowerShell. You can use PowerShell for the time being, but when we get to some of the later videos, I'll explain some problems with it. Mac or Linux, you can go ahead and use your native terminals. Windows, I recommend you follow the installation video and get this terminal here. Alright, so let's start with what cd is. So there's a command, and it's probably one of the most useful commands, called cd or change directory. And as we talked about paths in the last video, I think it's important that we know what cd does. And it pretty much allows you to change between your files. So it allows you to move forward, move backwards, and you can even go to direct paths. So instead of moving forwards and backwards by one step, you can go directly to some other path very far away in maybe a different drive or something similar to that. So I'm going to explain all of the variations of the cd command. But if you want to know the basic way to type or the basic cd command, it's pretty much cd and then you type the name of your path. So this could be some absolute path. So for example, I showed you in the last video, you could, copy the path directly from your Windows File Explorer and paste it in. Obviously that won't work because of the whole Ubuntu situation. but you can copy absolute paths and then just paste them in and go straight to them. The second way is to CD directly into a folder. So you can type the name of a folder inside of the path you're currently in. So right now, basically, I'm just going to create a little folder here. You don't need to know how the command works or anything. I'm just going to create a random folder. And now I can actually CD into that random folder. So let's say I have some important files in there, or I'm trying to get to my Git directory from the terminal. So I'm going to show you how to do that. You just type CD and then random folder. Now, instead of typing the whole thing out, if you type just part of the word, it is case sensitive, so watch out for that. If you type out just part of the word and click tab, it will autocomplete it for you. So that's just one really useful trick. And now you can see that we have this character / random folder. So this is our path. We have the default directory, and inside the default directory is our random folder. So now that we're inside of the folder, we can run whatever commands we want, but let's say we're in maybe a folder inside of our project containing maybe libraries or source code or something that we don't want to use because we're finished with it. So maybe we made a few commits, made a few changes. Now we want to CD out. So how do you do that? Now, one way to do it, obviously, you can just type CD and then your default path directory. Remember, we're following the rule of CD and then your path. And you could do that and it would just take you back. But what if you're maybe 3, 4, 5 levels deep? So one of the easiest ways to go back, and instead of, maybe going back to the start and then going forward 4, is just to type CD ... What this will do is take you back a level. So here you can see we're in /home. So this is the home directory of your Ubuntu operating system. So now that we're here, we can go forward or backward as far as we want. So I'm going to do CD ... again, CD ... And remember, / is the top level terminal. So top level directory. So that's one thing to keep in mind. So when you get here to /, what this is pretty much saying is you're at the highest level. Usually it would be your C drive on maybe PowerShell or command prompt, or if you're using Mac or Linux, that would be your home drive where your operating system is installed. So you can't really do anything from there except go forward. So you can do that perfectly. And what if I wanted to go maybe from my root here directly to random folder? Now, one way I could do this is CD, and then I can, go forward each time. So I want to go CD home, and then I want to go into CD, then I want to go into my, my default directory, and then I want to go from there into my random folder. You can see there's a lot of steps involved. Now, what if we don't want to do that? One easy way to skip this whole part, and I'm just going to go CD / is to go directly to our directory, the one that we want, just through an absolute path. So you can see one of the ways to do this is by using CD /, and what that does is take us all the way back to our top level directory. So you can see I went straight from our random folder from here straight up to our home directory without having to do CD ... CD ... That is an example of an absolute path. But it doesn't really give the example, or it doesn't really show what an absolute path looks like. So I'm going to show you how most absolute paths would look like for you. So what you would do is, for example, CD, and then you would go into whatever folder you want to use. So I'm just going to start with my default directory / random folder /. And that will take me directly from the top level to the random folder. And obviously I skipped my home directory here, but you get the idea. And you can do this as many times as you want. I'm just going to show you what it looks like. So let's say I go into my desktop here, folders, projects, my website. You can see this here is an absolute path. And it would look a little bit different, but I'm just going to show you how I can get directly into my folder here from the terminal. So this is a little trick that you can use, and I explained a little bit about it in the last video, but pretty much what happens is we're inside the Ubuntu operating system, so we can't interact with our Windows OS without doing a little bit of editing to our paths. So I'm going to do CD / firstly, And now what I'm going to do is change directly from here into our website folder that I created. So I'm going to type out cd, and if you want to paste something, you can't just do Control V. It doesn't work like that. You have to right click. And now all you have to do, you see I can't really do this because if I do this, it's going to give me an error. So what do I want to do? And obviously this is the incorrect error, but what do I want to do here? How do I fix this? So I'm going to do cd, and then I'm going to right click to paste it. And I'm just going to go straight into my projects folder like that. So what I want to do instead is start at the top level directory. So I'm going to do slash and then mnt. So this stands for mount. So this is things that are mounted into our Ubuntu operating system, slash, and then the letter of your drive. In this case, it's C, slash. And then from there, you can go straight into your folders. So I'm going to go and do that. And you can see there's a little bit of an error, and you can tinker a little bit, but pretty much what this allows you to do is go straight into your mount folder. So into your Windows drive. So from your Ubuntu terminal, from your Ubuntu operating system, you can go backwards and then forwards into your Windows drive. So I'm just going to do a little command here, and I'm going to go into my mount, and then I'm going to cd into C. So you can see there, don't worry about the ls command for now, but once we get to the top level, we can go straight into our mount directory, and from there we can select our drive, which is C, and then from there we can go and do whatever we want. So you can see everything is starting to look a little bit familiar now. Program files, users, things like that. So I'm going to cd into users. And remember, it is case sensitive when you tab out, so that's just a little warning. So now I'm going to cd into my directory there. And then from there, I can go into my desktop, for example, and then I can go into my folders, and you get the idea. So once you get used to it and you use it a little bit, you will start to, get the feel for using the terminal after a while, and you'll be able to do this really quickly. You can write 3 commands in a second. So just go ahead, open up your terminal and get some practice with the cd command and just messing around, go up and down paths, do all of that. And so you can just get a feel for how it works. So that's one thing you should do after this video ends. So now that we've learned cd, we're going to move on to some of the more specific commands, because cd is one of the top level important commands. So now we're going to move on to some more important stuff. So for example, creating and removing files. Alright, so I recommend you go ahead and get some practice with your cd command off video. So go open your terminal, just start playing around with cd, make paths, things like that. You can totally do that through your file explorer for now, because we haven't learned how to add and remove directories. But for now, all you have to take away from this video is cd and how the general rule works. So cd and then your path. You also have to know how to get into your Windows drive. So you want to go to your top level and then into mount and then into C. And from there, you can go into your users and then your user, and then you can access everything that you want from there. All right, let's move on. So in this video, I'm going to be talking about adding files and directories. So adding files and directories are some of the most useful tools, especially through terminal. Because you can create all sorts of different things with them, and it allows you to create a bunch of files in a really, really fast way. So it's a very efficient method for creating files and also removing them. So we're going to be talking about the commands in this video, but before we go forward, I just want to talk about one command that I've been using a lot, but I haven't actually given the time to explain, and it's the list command. So all you have to do is type ls, and that will list all of the files that you need for the project. So not for the project, but it will list all the files in your current working directory. So right now I have projects and work. So if I cd into my projects, for example, and if I list it, you can see that I have my website, my project website folder. So you can use that command to list all of the current files, directories, everything in the current directory that you're in. So that's just one command that you need to know. It's very simple. It doesn't have much behind it. So let's talk about actually creating folders. So folders I'm going to start with first. We should probably start calling them directories from now on. I'm sure that, just let's use some correct terminology. So a directory is just a folder pretty much. It allows you to store different things. So there you go. Let's get started. So if you want to create a directory, all you have to do is use one command, mkdir, or make directory. Remember it that way. And then after that, you type the name of the folder. So let's just say I want to type, let's say, school stuff. So I'm going to type school. I'm going to use a capital letter actually. And there we go. Now if I list, you can see that I have my school folder right there. Now if I cd into school, I'm going to cd into school. Now from there, let's just see what I can do. So from here, let's say I want to make a new folder, and let's just say it's for random, let's just say service stuff. So I'm going to make a new directory, and I'm going to call it service or after school activities or whatever you want to call it. So I'm going to do that, list it, and now I have a service folder inside of my school folder. So now I can cd into service, and there you go. You can see how this gets useful over time. So there you go. That's for making folders. You can do this for pretty much any situation you need it in. But let's say I want to remove these folders because you can see that I've created a bunch of folders and I don't really need them. So I'm going to cd out of here. So I'm going to cd back to my folders. I'm going to list everything. And now let's just say I wanted to remove both the school and the service folder. Now, just think about this for a second. What order should I remove it in? Should I remove school first, then service, or service first, then school? Just think about it for a second. Pause the video. All right, so now that you've thought about it, I'm going to show you the solution. So it's actually pretty simple. In order to remove both folders, you only need to remove one, which is the top level folder. And all you have to do is type rm -rf, we'll talk about what the dash does, and then the name of the folder. So I'm going to type school. And there you go. Now if I list everything, that school folder is gone, and so is the services. So there you go. That's how you remove multiple folders in one. All you have to do is go to the top level, and once you remove it, it removes everything inside it. Files, folders, or directories. You can do all of that, and it will be finished, gone. You won't have to, go through and individually remove it. And obviously, if you want to keep a folder, for example, you should go through and remove only the ones that you want to remove. But if you're trying to remove everything inside a directory, just go ahead and remove that directory altogether. So let's talk about this command for a little bit. Now, pretty much what the flag does, it allows you to sort of alter the properties of the command. So we're going to talk about the rm command in a minute, but what -rf does is signify to the command that we're removing a directory instead of removing a file. So rm is for actually removing a file, and we'll talk about creating and removing files in a second. But these flags can be used to alter the properties of a command. So one of the most common ones is Git. So let's say I wanted to check the version of Git. So all of our Git commands start with Git. But what if I wanted to view the version? So all you have to do is --version, and that will give you the version of Git. So it's actually a very, very useful tool, these flags, and there's many of them. Usually there's 10, 20, 30 flags per top level command, and it just allows you to alter the properties of that command. Okay, so now that we've talked about flags and removing folders, let's start moving on to creating and removing files. So I'm going to talk about the difference between PowerShell and our Ubuntu shell here for a second, but let's just talk about creating files in our native Unix shell. The way to do this is touch and then the name of the file. So I'm going to do file.txt. Actually, let's just go ahead with CSV. I'm trying to show that you can do any file that you want. Now, you do have to add a file extension. You can't just create random files and expect them to be Word documents or Excel spreadsheets. It has to be a specific file. It has to be a specific file extension. So once we do that, it creates the file. So once we go ahead and list it, you can see we have file.csv. Now, I'm not going to open it with the terminal, but what touch allows you to do is create files, exes, installers, spreadsheets, any file that you want, you can create through touch. Now, what if we, let's say, wanted to remove this, or I misnamed it and I don't want to go into the File Explorer and go back to folders and delete it? Well, simply just use the rm command. Now, I talked about the rm command and the flag here in our directory section, but all you have to do is just type rm. You don't have to add any flags because the rm command at its core is removing files. Then you just type the name of the file, and you can also use tab complete for the rm command. So there you go. Now I'm just going to click enter, and there you go, it's gone. Let's go and check our File Explorer. You can see it disappeared from there too. So there you go, that's the rm command in a nutshell. So basically, it's just a summary. To create folders, use mkdir, and to remove folders, you use touch. Now, if you want to remove them, you can either use rm for files and add the -rf or remove folder flag for directories. So now that we've done the summary, if you are on Windows, stick around. If you are on Mac or Linux or something that has a native terminal, you can go off now. But if you have Windows, I'm just going to talk about the dangers of using Windows PowerShell. So let's open this up, and I'm going to try and create the same file.csv on our desktop. So I'm going to cd into my desktop. I'm going to list everything. I'm going to cd into folders. You can also see the, it's a little bit different here. So I'm going to cd into my projects, for example. And now I want to try and create our file.csv. Oh, what's going on here? Something really weird happened. It says the term touch is not recognized as the name of a cmdlit function, script file, or operable program. So what this is saying is touch is not a command in PowerShell. It doesn't work because PowerShell was made to try and mimic the Unix shell, but it isn't a native terminal. It tries to sort of copy the commands, but it doesn't do a very good job at it. A lot of the commands are missed out, and obviously there's a lot more usability than something like the command prompt. So, features like ls would work on here, but on the command prompt, ls wouldn't be recognized. But how do we create files on the PowerShell? If you're still, really loyal to the PowerShell and you still want to use it, it's quite simple actually. All you have to do is type echo $null greater than, and then the name of the file. So it is a little bit more complex, but once you get it down, or if you just do a Google search for it, it won't be that hard. So now if I do file.csv, and if I'm going to list everything, you can see file.csv is right there. So now I'm just going to remove file.csv, very simply, file.csv, and there you go, it works. So you can see most of these commands are working fine, but even though it does a pretty good job of mimicking a Unix shell, it doesn't do it perfectly. And you can see one of the big flukes is the missing touch command. So that's just one of the dangers of using PowerShell. Alright, so we're finished with the adding and removing directories part, and that's pretty much all you need to know for the terminal. It's quite smooth and it doesn't really require much knowledge, but now that we know the ins and outs of the terminal, we can start moving on to some of the more important parts of this course. So Git and all of the Git commands and some of the workflow behind it. So yeah, let's move on. So now that you've gotten familiar with the terminal and some of the commands, and you're probably comfortable with the environment, we're going to move on to start working with Git. So since we're just starting out, I'm going to have to go through all of the workflow theory behind Git. Now, don't worry, this doesn't mean we're going through an introduction again. We're going to go through the process that Git does from the time you make the change to the time you add it to your repository. Now, don't worry, we'll talk about all those commands later. But here you go. This is just a quick section overview of what we're going to be doing. So first we're going to start with some of the Git workflow and how it all connects together. And then we're going to learn some of the commands to use, because once you have a theory or some general idea of how it works, we can move on to some of the more command-oriented parts. So we're going to start off with some of the theory. So this is just a little diagram. Don't worry about what this all means. I'm going to go walk you through step by step with a more in-depth diagram, and we're going to go through all of the different components of Git and how they connect together. So we're going to go through some terminology as well, the staging area, for example, committing, all of that we're going to talk about. And once we do that, we're going to move on to the commands. So don't worry, this isn't my picture. This is just one picture I got from the internet, but we're going to be learning some of the commands that we can use to work with Git so that we can actually start, implementing it into our course. All right, so let's get started. So now that we've gone through the introduction to this section, we're going to start learning a little bit about the Git process or workflow, how it all connects together, where it starts, where it finishes, and everything in between. Sorry about that. So we're also going to be learning a little bit of the terminology behind Git. So we're going to be learning about repositories, working directories, local repositories. We're going to learn all of that in this video before we move on to start using the commands. So firstly, I'm just going to give a little introduction to how Git works through from the start to finish. So before Git tracks the change, so before you commit the change to your source control, it goes through a long chain of operations and tasks. So it does a lot of things, and you need to do a lot of things before you manage to get that snapshot in time in your source control. So like I said here, many of these tasks are user controlled. You need to do them, and you need to manually input them in order for Git to work properly. So before we move on to some of the processes, let's just talk about repositories for a second. So I've used this term interchangeably with directories in the past, but they are completely different things. So repositories usually refer to the data storage that stores the full history and source control of a project. So it stores all of the changes and progress of the project over time. So these repositories can be either hosted locally, so on your machine, or they could be hosted on a shared server. So for example, GitHub, that's one of the most common uses of a remote repository or a shared server repository. So like I said here, most repositories are stored on GitHub, and then core contributors, people who work on the project, will actually make copies of these repositories on their local machines and using the push and pull system. So they basically take information and put it back into the repository. They don't store the central repository on their machine. They keep it on an external server, and then they simply interact with it from there. So the term for these shared server repositories are called remote repositories, and the repositories that you store on your machine are called local repositories. I'm sure it makes sense. Remote repository meaning that it's stored somewhere else. It's remote. So there you go. Let's talk about repositories or repos versus directories. So repositories are timelines of the entire project. Like I said, they track all of the changes from start to finish. Whereas directories are usually referring to the project in its current state in time. They're usually called the working directory, but usually when people refer to the directory of a project, they're referring to the project at its current state. Whereas the repository has the full timeline of the project, from when you created the first file to when you just created the 100th file and your millionth line of code. Of course, that's an unrealistic example, but you're kind of seeing what I'm saying here. So technically, any directory that has source control installed on it is a repository itself, but it's better to call these local repositories, as I said in the previous slide, because usually they are stored on some sort of shared server and you interact with them. So that's what most people do, is they store them on GitHub, for example, and they simply pull and push from that repository. So anything that's stored on your machine, any repositories, directories, are usually called local repositories. So now that we know a little bit about what repositories are, let's talk about this workflow diagram here. So I know it looks a little bit complicated, but I'm going to go through each step and explain what it does. So we start with the working directory. This is your project at its current state in time, as we just explained. It contains all of your files, everything at its current state, so when you're working on it. So let's just say you made a new file, called it, let's just say script.py, for example, a Python script. Let's just say you added this and you wrote some code in that script. So now you want to change or take this and take a snapshot of it and put it in your source control and say, okay, I made a new file called script.py and I added 10 lines of code to it. So the first thing you do is obviously make the changes, but then after that, what do? Do you just automatically write some code or put some command in the terminal and it just does everything for you? No, you actually have to do a few things before that. So there's this thing before you commit, it's called the staging area, and a commit is just pretty much taking a snapshot and putting it in source control. So we're going to be calling it commit from now on. So before you make your commit, there's this thing called the staging area. And what the staging area does is when you commit, it takes all of the files, modifications, all of the changes listed, and it takes this, bundles it up, and puts it in the commit. So for example, in the staging area right now, we added a file called script.py, we modified the file, and let's just say we removed 10 lines from our HTML website. So it would have, we added a script.py, we added 10 lines to this, so we modified it, and we removed or modified our website.html file. Let's just say that, 3 modifications. Now you can add and remove from the staging area. It's asynchronous, so you can take and remove as much as you want before you commit. It's not like as soon as you add, you commit. That's a completely separate step. So let's just say that you do this and all of that, but let's just say you don't want to track or you don't want to you added a script.py file inside your commit. So let's just say you don't want to put it in that snapshot. So what you would do is remove it from the staging area. And we're going to talk about adding and removing files and doing all of that in the future videos, but that's what you do. So you would keep going through this back and forth cycle. And once you have the files, all of the files, modifications that you want, you would commit your changes with a command and it would put them in the local repository. So this is what I wanted to talk about, the local and remote repository. So pretend that this is your repo stored on GitHub. So this is going to be your central storage. And before that, what you would do at the start of each session is pull all of the information from your remote repository and make a direct copy of it on your local machine. Now, once you made all the changes, so let's just say you make 10 commits over the course of 4 hours. Now, it's a little bit unrealistic, but that's not what we're talking about here. So you've clearly changed the local repository. We've made a bunch of changes and right now the remote and local repositories don't match. So now what you would do is, okay, I'm done for the day. I made all my commits. You would then push it to the remote repository and now they're both matched up. And you would continue this cycle until your project is finished or until you don't want to work on it anymore, pulling and pushing and staging area and making commits. And overall, it just goes through this cycle until you don't want to work on your project anymore. So you can see that Git has a much more complex workflow than other source control. And of course, it's mostly the same, but it's a little bit complex. You know, you have to go through adding things to the staging area, then committing it, then putting on our remote repository. And for now, we're not actually going to use any push and pull or remote repositories. Well, we're just going to use one local repository. But for the future, when you learn all of the different features of Git and remote repositories, it is better to follow this model because if you store it locally, you miss out on a lot of opportunities. I mean, it is possible to add, collaborations with others, but it's better if you put it on GitHub because you're missing out on a lot of opportunity. And on top of that, it's much safer to put it on somewhere like GitHub in case of, let's just say your hard drive gets damaged, for example, and your local repository is gone, finished. And there's been a lot of stories of people who work, years on projects and they're on their local repository and then their hard drive gets damaged or maybe, gets burned out or something like that and they lose all of their work. So once we get to that stage, we're going to put everything on a remote repository and I'm going to teach you about following this model exactly. But for now, you just need to know about this part. So forget about the remote repository and push and pull. We just need to know that from there, you make changes, you modify the staging area. So what you want added, you take a snapshot and you put it in your repository and you repeat over and over again until you're finished. So that's all I wanted you to take away from this video, just to know a little bit about how Git works, the processes that take place in order for Git to work. So in the next few videos, we're going to be working towards learning some of these commands. So for example, adding and removing from the staging area, committing. We're going to learn about interacting with our repository. We're going to do all of that in this section. And then we're going to move on to our remote repositories, where we start working on interacting with GitHub. All right, let's move on. So in this video, we're going to be creating our first repository. So I know you're probably thinking, well, when do I get to actually use Git? Can't I just go into a folder and start working with adding and committing files? Well, it's a little bit more complicated than that, because you can't just go through and start adding files and committing them just out of the blue. What you need to do is create a repository. So more specifically, a Git repository. So what you need to do is we are going to create a folder or a directory. Then we're going to use a command to turn it into a Git repository. Once you turn it into a Git repository, it can then store all of the information and all of the different commits on that directory. So you can't just do it without using this command to initialize a Git repository. So from here on out, we're going to be doing it in a sequential order. So we're going to be following on from the last video, and we're going to be doing it, a lot of it in a practical way. We're not going to just cover theory and talk about how to do it. I'm going to actually show you how to do it. So I highly recommend you follow along and create with me, because I find that learning by doing is the best way to retain information. So just go ahead and follow along. You can obviously, mess around, experiment a little bit. That's the best way to learn, in my opinion. Alright, so I'm going to go ahead and create a new folder in projects, and I'm just going to call this my software, or my software. Yeah, I'm just going to call it that. So this would be me starting a brand new project. So let's just say I have a really good idea for some software or a web application. So now I created the directory for it. Okay, there we go. So now I want to initialize this repository. Now I'm going to show you what's going to happen if we try and run any Git commands in this folder. So first of all, let's go ahead and open our bash terminal. And now let's go ahead and move into our projects folder. So I'm going to go cd ... to go to the root. And I'm going to cd into mount. Then I'm going to cd into my C drive. Then I'm going to cd, first I'm going to actually list it. And I'm going to cd into users, list, cd into my user, cd into my desktop, then cd into my folders. And you see that I'm doing this quite fast, because over time you will get the hang of this and you will get used to it. So that's why I'm saying go ahead and play along with me. So now I'm going to cd into my projects, and there you go. Now I'm going to list everything, and now I have my software. So I'm just going to go and cd into my software right here. Now, what I want to do firstly is I'm actually going to copy this path because it's quite long. So I'm just going to copy that. Hold on. And I'm going to actually put it in a new notepad document so that I can, just refer to it later on when I want to change directories. So this is going to be a pretty good example of making our first commit. So I'm going to go and try and make a new text document, path for terminal. And of course, usually we'd call this by a lowercase name with dashes just to make it a lot easier to read with the terminal. So I'm going to open this, paste it, Control S or Command S, depending on where you are. I'm going to save that, and there you go. So now I want to commit this. So let's say I want to first add everything to the staging. So I created a brand new text file, so now I want to add it to the staging area. So I do git add. Of course, you don't need to know this command yet. Let's see what happens. Fatal, not a Git repository or any parent up to mount point /mnt. So what this is saying is this isn't a Git repository yet, so we can't really do anything. We can't work with any Git commands or store history or anything like that. So before you run any Git commands, there is one command that you need to use to initialize a Git repository. It's git and then init. And make sure you're in the correct path, because if you can't undo this. This is irreversible. So once you press enter here, this path will become a Git repository. So make sure you don't do this on your root folder. That would really be disastrous. Git init. Now it says initialized empty Git repository in the path here. So we can see here that it added a new folder. So it's .git, and what this is going to do is store all of the history and all of the commits for our directory. So this is what I was saying about repositories, is they store all of the history of the project. So you can see there, I have all of my branches, my hooks. We're going to talk about all of this later on. But now I can actually start using git commands. So we're not going to make any commits yet, but now that we've set up our Git repository, we can move on and start messing around with adding commits, adding things to the staging area and all of that. So just make sure that you are in the correct path of your folder. And once you've done that, your challenge is to initialize an empty Git repository. So I'm just going to close that down. So that's pretty much it for creating an empty Git repository. It's very easy to do. It's one simple line, but you have to do this in order to make sure that you have a Git repository installed. It's already there and it's ready to be used. So that's the command you need to use. Go ahead and do that with as many folders as you want. I'd recommend you start with one for now so you can get a feel for it. And once you do that, you can go through and start messing around with all of your different projects, making them Git repositories, things like that. All right, let's move on. So in this video, we are going to be starting to work with some more Git commands, and we're going to start to experience some of the more of the processes that we explained in the introduction to Git. So for example, adding and removing files to the staging area. We're going to go through all of that in this video. So first thing I want to do is go ahead and open up my project folder. And if you remember, in my software, or whatever you named your folder, I saved a path to the terminal, or for the terminal, so that I can get to this very easily through our Ubuntu shell. Now, like I was saying, you should know this if you're on Mac or Linux by now. You don't need to do this. You don't need to go to, your mount and then your C drive. You just need to copy the direct path from your from my software, or to your folder from your root drive. So you just need to do that. It's quite easy. But for Windows users, make sure that you have this path. And like I said, I've already explained it. So just to clarify, you need something like this if you have the Ubuntu terminal. All right, let's get started. So before we move on, I just want to do one thing. And for naming convention, I'm going to rename this to path for terminal with dashes. So I'm going to path like this, path for terminal. And the reason I'm doing this is because once you add spaces to a file name, it becomes very difficult to work within the terminal. So this is just a common naming convention. If you've ever dug around software, source code, or files, you'll notice that a lot of them are lowercase and usually don't have spaces. So that's just something to keep in mind. There we go. All right, so now that that's done, I'm just going to copy this and I'm going to open up my terminal and paste the path in. So I'm going to go cd and then right click. So it's going to take me up to my root, then to my mount, then C drive, and all the way down to my software. You can see that works perfectly. And there we go. So now I'm going to list everything we have here. And now that we have a Git repository initialized, we can actually start to work with our staging area. So I've already explained what a staging area is, but for those of you that maybe skipped through that video, it's basically the bundle of everything that you want to package in the snapshot. So all of the modifications you've made, the changes, everything like that. So we're going to be working with the staging area in this video. Now, if you want to check what your staging area looks like, all you have to do is type git and then status. This will give you something right here, giving you the status of your staging area. So it says on branch master, no commits yet, untracked files, use git add file to include what will be committed. So you can see that the staging area right now is empty and there's no commits. So you can see that we have an untracked file, which means it's not currently added to the staging area. It's not being tracked yet. So what we want to do is add this and then make our first commit in the next video. So I'm going to be teaching you how to add these to the staging area. So usually what would happen is you go through, maybe you add a new script, Python file, JavaScript file, whatever you're using. Maybe even you're just writing an essay and you just want to make backups. Remember, Git is not exclusive to tech. It can be used in almost anything. So let's just say you made some changes, maybe a few new files, and you want to start adding these. So one way to do it is to add each individual file. And the basic rule for Git adding is using git add and then the name of the file. So in this case, I want to add path for terminal.txt like that. Whoops, just going to erase that. There we go, just like that. And once you do that, and I do git status to see the staging area now, you can see that changes to be committed, there is path for terminal.txt. So now we've added the creation of path for terminal.txt to the staging area. So think of this as in the staging area right now, there is one change. We added a new file called path for terminal.txt. So there we go. Now what I'm going to do is just touch a bunch of new files. So we're going to do file.txt, touch script.py maybe. I'm going to make just a bunch of new files so I can prove a point of adding multiple files at once. So let's just think of another one, website.html, touch style.css. So if you don't need to know what these file names or extensions means, but you can see that there's a bunch of new files here. And if we go to git status now, let's see that. You can see there's a bunch of untracked files. Now, one way to do this is to go through and add each individual one, but we're not going to do that because it takes a lot of time. So what is one way to add all of these files together and put them in our changes to be committed? In order to do this, all you have to do is do git add and then dots. Now, if you haven't seen the dot notation anywhere else, it basically signifies everything or all, especially in regular expressions, it's used in that sense. So that's kind of where it comes from. Dot basically represents adding everything. So we're going to go and do that. Now let's check git status. And there you go. You can see in our staging area, basically what it's saying, we added 5 new files and then the names of each file. So there we go. Now, let's say I want to maybe remove some of these files or delete them. Let me just show you. So I'm going to delete my Python file and my cascading style sheet, my CSS style sheet. Now I'm going to go to git status. Now I didn't do it through the terminal, and you can see that it still says 5 new files, and that's because 5 new files were created and then 2 files were deleted. So what I can do now is commit these changes, git add dot. Now I do git status, and you can see that it says 3 new files, file.txt, path for terminal, and website.html. So there we go. Now you can see that we have added 3 new files. And remember, it's not saying 5 new files and 2 deleted anymore, because we added them to the staging area, so they kind of cancel each other out. But remember, if we made a commit, in that case, it would be 5 new files in one commit, and then we made another one saying we deleted 2 of them. But we'll get into the whole commits and how it works in the next video. Now, we deleted the files legitimately, and absolutely, we deleted them and put them in our recycle bin. But what if we want to not track the files? So we want to remove it from the staging area instead of deleting the whole file. This can be done for many reasons. For example, large automatically generated files, especially in game development, a lot of files are generated every time you open it. So many of them are not tracked because they take up a lot of space. And because you don't need to track them, you can go back in time and it will build and everything will be fine. A lot of them aren't tracked. Now we're going to be talking about not tracking them permanently in the next few videos with something called the gitignore. But if you want to remove it temporarily for any reason, all you have to do is type git rm and then the name of the file. In this case, I'm going to do file.txt. There we go. It says error, the following file has changed stages in the index. So pretty much what this is saying is that we've already put this file in the staging area, and the following file has changes staged in the index. So this is saying that we've already made changes and adding it, so removing it is going to cause some contradictions. Now the easiest way to get rid of this error is to do git rm and then -f to force remove it, file.txt, and there we go, it's gone. So now if I list it, sorry, not listed, I'm going to check the status actually. You can see that we have our new file, path for terminal.txt and website.html. So there you go. We can see that it is working fine, but we can also see that where did our file go? And well, it just disappeared. We went to remove it from our We meant to remove it from our source control, not completely. So pretty much this is the problem with force removal. What this does is just completely wipe out the file.txt. So how do we get around this? I'm going to make a new file, same one, file.txt. Whoops, I made an error there. And now I'm going to add it to our source control. Now I'm going to check the status. Alright, so now that we've, added, deleted some of our files, we've messed around with the staging area a little bit. But the deleting that we did was actually deleting the files. What if we want to just remove it from the staging area? Well, it's actually quite simple, and it's right up here. Use git rm --cache, the flag, and then the file name to unstage. Very simple and very easy. So let's say we don't want to track this file.txt. This can be for many reasons. For example, it's automatically generated, so you don't really need to track it because it can be rebuilt at any time. This is especially done in game development, and there's just many different reasons that you want to do this. But if you want to, all you have to do is git rm --cached, because normally git remove will remove the file entirely. So you want to do --cached, and then you put the name of the file. There we go. Now let's go ahead and check our Git status. So there we go. Now we have our 2 files being tracked, 2 new files, but then we have 1 untracked file. So there we go. That's very simple, and we have basically untracked it. And this will continue to be untracked until we commit. So there you go. That's basically what I wanted to cover in this video, removing files and just doing all of that. So in the next video, we're going to actually go through taking the staging area changes, adding, removing files, unstaging them, and then we're going to actually bundle it all up together and put it in a commit. So I'm going to teach you how to do that in the next video. All right, let's move on. So now that we've worked with the staging area a little bit and we've looked at adding and removing files, why don't we go ahead and start working on making our first commit. So we're going to make 1 commit in this video and 1 commit only, because I want you to get a feel for how the whole process works. So we're not going to go and do 5 commits, add a file, then commit. We're just going to do 1 commit so you can see how the process works. So I'm in my path right now. If I go ahead and check the Git status, you can see that I have all of my files. I'm already tracking everything, and I'm actually going to add this to the tracking. So I'm going to go git add dot, and that's going to add all of the currently untracked files. But now what I want to do is make a commit, because we don't actually have any commits yet. So before we move forward, just a quick note on what a commit is. Now, I know we've already explained this, but just for a little bit of revision, a commit allows you to just take a snapshot of all the changes and modifications you've done at the time and store them in a tree. So there you go. That's what a commit is. Now we're going to start actually making our first commit. So I'm going to go ahead and check my status, make sure I have everything. You can see we created 3 new files. So let's go ahead and make our first commit. So one thing I'd like to say is the different types or flags on the commit command. So the command for actually creating a commit is git commit. That's it. But there's a few things we need to do before that, and there's a few things we need to do after it. So if I just type git commit, it says here, please tell me who you are. So you actually need to configure your name and your email before you start working. So you can see it says fatal empty identity name for my user.local domain not allowed, because you need to log in. So we're just going to follow the commands they gave us, git config --global, because what global does, it allows you to log into across all of your terminals, so you can just use it in any repository. So now we're going to enter my email. So I'm going to enter my email. And in fact, let me just go ahead and make this full screen so you can see everything. There we go. Now I'm going to configure my username. Config --global user.name. And I'm going to put my name there. There we go. Now I can start making my commits. So before I do that, I'm going to actually do --help so I can see some of the different things I can do with commit. So you can see it brings up this huge menu that allows us to sort of interact with this, because it brings up a Git manual, sort of like a GUI in the terminal that we can use to go through and see how it's working. So let's get started. So first thing you can see here is synopsis, git commit, and then there's a bunch of different flags. The most common flags you're going to use is -A and -M for the message. So those are the two most common. And I'm not going to go through all of them, but if you want to, just do git commit --help, and you can go through and just look at everything so you can know how commit works. But I wouldn't recommend using this manual. I'd recommend going onto Google maybe and searching how to, all the different flags for git commit, because this is a lot more user friendly. You can just see everything easier. So let's read some of this stuff. So the description stores the current contents of the index in a new commit. And basically what they mean by the index is the current staging area. So everything at that current point in time in a new commit, along with a log message from the user describing the changes. So this is one of the most useful features of commits. You can actually include a message, just a little summary of what happened in that index or in that point in time. For example, added new script files or removed this and that function, all of that. So you can do that with the log message. So there's a few other things here. We've already done git add, git remove. We've done everything here, so we don't really need to go through it. So I'm just going to press Q to quit, and we're back here. So now let's actually go and make our first commit. So we're going to add all of these new files. Git commit -m, the message flag, and then in quotations, you're going to put your message. So I'm going to say added new files. But usually for your first commit, what you would say is initial commit. Just like that. Now this is the standard first commit message that you would put. And once we get into GitHub, if we set up a template repository, you can see that there's already one commit saying initial commit. We'll discuss that later, but we're going to go ahead and do this. It doesn't really matter what you put in there. You can put anything you want, but just to follow convention, we're going to put initial commit. And there you go. Now it gives us this little message saying master, which is the branch. We'll talk about branches in the next section. Root commit, and then the ID of the commit. We'll talk about that when we talk about checkout. Then you have the message, and then it talks about all the changes. So 3 files changed, 1 insertion. So create mode 10644. So this just means you created a new file. We created a new file, created a new file, created a new file. There we go. So that's pretty much it for committing files. It's actually quite easy. There is one thing I would say though. If you want to commit all of your tracking or commit all of your tracked files, because git commit -m, if you don't include a certain flag, it'll take all of the files, tracked files, non-tracked files, and put them all in the commit. So if you want to commit untracked files, you just do git commit and you add the -a flag, and then you add your message flag, just like that. So that allows you to add all of your tracked files. So there you go. That's just one thing to keep in mind for the future when you start committing things. It's quite a useful tool. Okay, there we go. So we learned about commits and, making commits, but it's not really useful unless you can see your previous history and your commits and everything, because otherwise you're just creating snapshots for no reason. So how do we actually look at all of our commits? It's actually quite simple. All you have to do is type git log. And what this is going to do is bring up a list of all of your commits. So you can see here you have commit and then the ID, which is, it's quite a long string. Then you have the author. So this is what I'm talking about, contributors and all of that. So then you have the date, Friday, September 7th, and then the time, everything like that. So as you add more and more commits, they'll show up on the log here. With something like SourceTree, you could easily go through and view all of them very quickly. But if you're using it from the terminal, this is how you're going to view your commits. It also says the branch here, and it says the head. We'll talk about the head system in just a couple of videos. It's basically a pointer referring to where the current state and time is. So we'll talk about that in a few videos, but this is your commit, right? So in the next video, we're actually going to go through and use something called Git Checkout, which is going to allow us to go back in time and view our previous commits so that we can actually look at previous code, things like that. We'll also use a few more features, things like that. So we're just going to end it off with this video. We learned how to commit, and if you want to check your log, you just do git log. Make sure you include the -a flag if you want to include all of the tracked files, and the -m flag to include a message. So that's pretty much it for git commits. Like I said, in the next few videos, we'll be working with our commits that we made. I'm going to add a few more commits off camera, and I challenge you to do that too. And don't just work with adding and deleting files. You want to go into these files and make changes to them. Just experiment around with how you can work with commits. So go ahead, do that, and then when you're done, maybe add 3, 4, 5 commits and come back to the next video so we can start working with these commits. All right, let's move on. So now that we've created our first commit, we're actually going to be looking at moving between our commits, because all we can do now is commit and look at our commits. We can't really do anything with it. The whole point of having source control is being able to track your history. And what's the point of tracking your history if you can't go back and see what's there? So let's go ahead and check it out. So there is actually a very special feature in Git called Checkout, which allows you to move between branches, commits, all sorts of stuff like that. We're going to look at it in this video. So I held on to my statement at the end of last video, and I did actually add a few more commits. So I did a few things with these commits. I removed some files. You can see I modified text and deleted the website. I added a new website and some new website functionality. So we're going to be going through and looking at this in the video. So here's an imaginary scenario for you. Let's say I created this website and I worked on it and stuff, but I then deleted the website because I wanted to start a new one. So I did all of that, but then I realized that the new website wasn't really what I was looking for. So what if I want to go back in time and look at my old website to see and compare if they match up and see if I'm really making a mistake here. And then if I am making a mistake, I can revert and go back to my old website. I'll show you that in the next video. So let's go ahead and do that. So what you want to do is, first of all, let's talk about the head system. So there's this thing called the head, which is pretty much a pointer that allows you, it's basically your point in time. So right now the head is at the master branch, which is the latest commit on the master branch. So the one that you start off with, that you work with towards the end. So right now it's on the master, which means we're at pretty much the working directory. We're at our current point in time. But I actually can move this head around to different points in time. I'll show you what I mean by that in just a second. So let's go ahead and talk about Git Checkout. What does it do? How do we work with it? So let's go ahead and do this. Basically, what we can do with Checkout is paste in a certain commit ID, which is why we're using the log here, and go back in time to that commit. And we're going to actually see the changes happen here in our software folder, in our repository. So let's go ahead and do that. First thing I want to do is go ahead and copy the commit that I want to revert to. So it's right here. It's modified text and deleted website. So this is the commit where I deleted my website. Now, we don't actually want to use this. We want to use where we actually have the old website. So let's go ahead and do that. But again, it's totally up to you which commit you want to move back to. Let's just say maybe you made a big error in your text and you want to move back to when you first created the file. This is why the message in the commits are useful, because if you don't have something like SourceTree, you can't actually look at the changes that you have. So it's really useful to have some in-depth messages. Now, they don't have to be entire paragraphs, just a quick phrase summarizing what's happening so that you know which commit to go back to. So I'm going to go back all the way to my initial commit. Now remember, doing this does not delete our commits. We're just going back in time. So let's go ahead and do that. Here's how you do it. You do git, then checkout, and then after that, you paste in the name of the ID or the commit that you want to check out, just like that. And once we do that, we press enter, and there we go. You said you're in a detached head state. This means that the head is in a different commit. So if we actually look at git log, just do this for you really quick, you can see that our head is at our initial commit. Now remember, this doesn't delete it. This means we just went back in time, which means you can't actually see anything. So this is really cool. Now, remember, if you go ahead, and I'm just going to give you a little example here. For example, let's say you go to your C drive and you create a Git repository. By the way, that's a very bad idea. Never do that. Let's say I create a commit, right? So I create it, everything's working. Now what I'm going to do is, after maybe a year or so of using my computer, I make another commit, and then I revert all the way back to the commit I made 1 year ago. That is going to shift all of the changes you made back to that state in time. Now, it doesn't mean that you can't go back. With a checkout, you can. With a revert, you can't. That's a different situation. We'll talk about that in the next video. But it will move all of your changes. You're basically almost in a time machine. You're going back in time to 1 year ago when you made that commit. Okay, so you can already see that there's a few changes. You saw this new website file that we had. It's no longer there. We can't find it because we went back in time to our original commit about 20 minutes ago. So this is really cool, and I really like Checkout. It's one of the best features that we have, because what you can actually do is go through and look at everything at that current state in time. So you can see that this file is empty, and up here in this log it says modified text and deleted website, but this is later in our file, so nothing is here. So for example, let me just say I wanted to check out the other one here. Now, I'm not going to do it, but let's just say I just paste this commit ID in, and I go and I check it out, and then that file will be there. So let me just go through and teach you how to do that. So if you want to go to, for example, this commit where you modify the text, let's say you had some important text in there that you deleted, and you want to get it back. So the first thing you want to do is go back to the top level. What you would do is Git Checkout, and then the name, you would type master. So this would take you all the way back up to the master branch, which is the latest commit, just like that. And there you go. Now you can see all of our files are there. We have our text, everything here. So now we're back up here. So now I want to go back down to where we deleted the website. So I'm going to go git log, and we're going to find that commit. Right there it is, modified text and deleted website. We're going to copy that. I'm going to go git checkout, and then right click. And then we're going to click enter. That is going to give us the whole detached head state. And now you can see that that website is gone, because deleted website, that little summary is giving us a sort of rundown of what we did in that commit. So there we go. Now we can go and look around, maybe look for the information you have. But once you have it, and once you've made your comparisons and looked at everything, all you have to do is go git checkout master, and that will take you straight back up to your latest commit. So now you can see we don't have any detached head because we're back up at the top. We've come back to the present, and our head is in the correct place. So there we go. That's pretty much all there is to know about Checkout. Of course, we're going to use Checkout in the future with branches, which makes it a lot more complex. But for now, we're only using one branch. So you can only go up and down. You can't really go left and right and diagonal. So once we introduce branches, this becomes a lot more complex. So I'm going to take you through step by step in the next section about going through branches and everything to do with that. But for now, we've learned a little bit about Checkout. So I encourage you to go and move up and down through your commits so that you know what's going on. And from there, we can pretty much do whatever we want. Let's just say, for example, we make like 10 new commits, and we don't want to, we want to go back in time to one of them to copy some important code or cache that we had in one of the files. You can do that and it will work perfectly. So yeah, that's pretty much it for Checkout and moving between commits. In the next video, we're going to be going over actually reverting. So we're going to completely erase the history. So let's just say we go back in time to the 1800s and we set that as the present time. So we're going to go through and I'm going to explain some of the dangers with Git revert. All right, let's move on. So in this video, we are going to be talking about some different types of the git reset command, because there are actually a few flags that can completely change the way this works. So a little bit of a recap. In the last video, we were looking at two git commands, which are revert and reset. So we were, trying to use them to fix errors, or if we wanted to, maybe remove something that we didn't want. And we looked at that, but there are actually many different flags that you can use with one of the commands, which is resetting, and they can completely change the way that you use the command. Because right now you probably think that git reset is only if you want to completely destroy something, but there's actually a lot of different uses for it, and we're going to go over them in this video. So there are 3 different types of flags: soft, mixed, and hard. And pretty much all of them kind of work in the same way in that they remove or change something, but they kind of work or remove them in different ways. So I'm going to go over a very overview-ish version without trying to get into technical details, because that would make it really complicated. So when you use the soft flag, pretty much what you're doing is, all you're doing is changing the actual commit. So let's say you want to move back in time 1 commit. Pretty much what you do is when you use git reset soft, it's going to go back 1 commit, but it's not actually going to remove any of the changes you've made. You're still going to have all of your staged files, so everything that's ready to be committed, all of the changes in your working directory or anything you've been working on, and everything will still be there. Pretty much, if you create a new commit as you were working on it, it's just going to undo the reset you've done. So it doesn't actually remove anything. The only thing that it's getting rid of is some commit, but it's not actually permanently removing any files. So the main purpose to, do something like this would be to fix something or a mistake that you've made in a commit. So for example, and I know this has happened to me definitely a few times, is you're just really typing commits fast and you want to get it, quick and rush through, but you end up making a spelling error or a mistaken timestamp or something like that, and you don't want that. But again, why would you want to revert hard when you can just get rid of make a new commit when you can just get rid of the spelling error by using this command? Because all you have to do is use git reset soft to go back 1 commit, and then you recommit with your spelling error fixed. So pretty much all you're getting rid of is the kind of name stamp that holds all of the content over something. So the next one we're going to talk about is mixed, and this is a little bit complicated because it's kind of in between resetting hard and resetting soft. So firstly, this is going to be the default command or the default flag, for git reset. So you don't actually have to specify it unless you really need to do so for some reason. So pretty much git reset mixed works in the way that it still keeps all of the changes or things you've been working on, but instead of having all of your staged files, pretty much what happens is you move back in time and now they're in your working directory. So think of it this way. Let's keep going with the example of 1 commit. So we want to move back in time 1 commit. Now we've already staged a bunch of files, so we use the git add command to add all of our files, and now they're staged. But pretty much when we move back in time, these changes are no longer there. They're not staged and ready to commit. So what's going on here? Pretty much instead of having it staged or inside ready to commit, all of the changes that you've made are now in your working directory. So although it doesn't look like anything's changed, it actually has, because it's no longer ready to commit. If you wanted to, let's say, commit it, what you'd have to do is re-add it again and then commit. So you could pretty much match this up with soft if pretty much what you did is went back in time 1 commit using mixed and then added all of the files to the staging area ready to be committed. This would pretty much give you the exact same effect. But instead of, trying to get rid of a spelling error, this would be much more useful if you maybe accidentally committed a file that you don't want, or maybe you've committed some errors or changes that you don't want in your repository. So let's take this example. Let's say we have a very large file that we don't necessarily need to commit. Maybe it's over, 200 megabytes or something like that, and we accidentally commit it. So what would we do from there? Pretty much the easiest way to fix this is just use git reset mixed, go back in time 1 commit, and then add all of the files that you've been working on, but leave that one file that you've accidentally added out. That way you can recommit everything without the file. And you could use things like git revert, and there are so many different methods, but this just keeps it a lot cleaner without having to create more commits that are just kind of adding on to the problem that you've created yourself. So the final one, which we've covered in the last video, is hard. So this is the strongest out of the 3. Now pretty much mixed removes it from the staging area. All of the changes that you've made are now in your working directory. This is kind of the final frontier of your git reset journey. But once you use git reset hard, it takes all of those changes in the working directory and completely removes them. It's as if those commits never happen. And this is going to be the most common use for a Git reset, is to completely get rid of some amount of commits. There's no data or no evidence left that those commits ever existed, because all of the changes that you've made are not in the staging area and they're not in the working directory. So pretty much this is much more useful for when you've created some irreversible error in your program. And this has happened to me quite a few times, is where maybe I accidentally compiled something wrong and it just crashed everything and would not open. Now, simply going back in time and recommitting the things wouldn't really fix that. And although it would work in some cases, in mine it did not work. It was just messing up with the memory and you could not open it no matter what. So the easiest way to do this would just to be go back in time to a working point where it was safely running and as normal, instead of having to, completely destroy your program, because that would really destroy a lot of the work that you've been working on, especially if you have, thousands and thousands of changes. Changing or deleting the program as a whole wouldn't really apply. So this has definitely saved me a few times, and that is why git reset hard is the most commonly used. It's a really good fail-safe, and is actually one of the main reasons a lot of people use Git in general, is to kind of create a fail-safe, so in case of maybe errors or something goes wrong, there's an easy way to just move back and forward in time to fix that. Alright, so that's pretty much it for, git reset and the different flags to use with it. It's a very complicated command as you move deeper into kind of the technical parts of it. But for now, this is all you really need to know, is where each one can be applied and what it can be used for. Alright, let's move on. And I'm going to be talking about something called a git ignore. So what is a git ignore? A git ignore basically allows you to sort of untrack files or keep them untracked permanently, or as long as you keep them in the file. So it's a file or a list of all of the files and directories that you do not want to track. So why would you use something like this? Well, there's a lot of files that you may not want. So for example, auto-generated files are very large and can be generated at any time. So if these files are similar to either one of those properties, you might not want to track them, especially because they can be rebuilt at any stage in the commit and it won't cause problems. So those are some examples of some files that you might not want to keep. So what I'm going to do is just create a new text file here. It's just going to be something called log.txt, and basically pretend that this is an auto-generated file. Every time I sort of made a difference or made a change, it would log the changes in this file. So I'm going to go and open this and type everything in. So just pretend that this doesn't really impact the project in any way. So firstly, let me just go and open this file right here, and I'm just going to say, I hope you enjoy. So pretend that this is the only file that I'm editing. I'm not editing anything else, but I go into my log and it also logs it. Pretend that that's a log. Let's go and check our status now. Now, I actually did this before just to test it out, so you might see, oh my god, sorry, there we go. So you can see right here that we actually have something here. So we have modified file.txt, and then we have an untracked file, log.txt.txt. Of course, you can see I named it log.txt without using the terminal, so of course it's log.txt, that's the name, .txt. Don't worry about that. So we don't know what this file is, what's it doing here, so we don't really want it. So let's just, commit it for now. We're gonna add all of our files, commit it, but the thing is, we don't really want these files because some of them can get really, really large, and over time it can make your project very slow, and if you want to commit, it's going to take much longer than it should because all of these files are so big and you don't really need them. So I'm going to just say modified text file. Just going to do that. Let's check our git status. There we go. So there's nothing there. So let's just make another change. For example, I'm going to go into my new website and I'm going to add another exclamation mark, and I'm going to add my log. So I'm going to log it into my auto-generated file. But the computer or the software would do this. And now I'm going to check my status. And there we go. You can see that it said modified log.txt.txt. And then we keep committing and adding. And you can see how this gets a little bit daunting and tedious after a while. Because if you want to untrack these, you have to do this every single time you want to make a new commit, which is going to get a little bit tiring after a while. So how are we going to fix this? Well, this is where our git ignore comes in. So I'm just going to finish this commit. There we go. So this is where our git ignore comes in. So I'm going to create a new file called gitignore.gitignore. Doesn't have a name, so it's just dot and then gitignore, which is the file extension. Now if we go back into here, you can see there's a file with no name, so it doesn't have a name. So you're going to open it up. And now we have our .gitignore. So let's talk a little bit about how the gitignore works. Pretty much, you're just going to input the names or the, oh, whoops, didn't mean to do that. You're just going to input the names of all of the files and directories you want to ignore. So I want to ignore my log.txt. What I would do is go log.txt.txt because that's the name of the file. I know it's a little bit confusing, but just bear with me for the time being. And let's say I wanted to ignore my home page as well because it's a static file. We don't really need to track it. So we're going to go homepage.jpg or JPG. There we go. So now we're no longer tracking these two files. But before that, I just want to organize this a little bit more. So I'm going to use hash and then I'm going to input a comment to identify these. So I'm going to say auto-generated files. And then I'm going to say static files here. So things like images and other static files. So the hash followed by anything is going to be considered a comment. It's not going to be read by Git in this file. So what if we go ahead and check the status now? Let's just say I'm going to edit my log and I'm going to edit my file. So I'm going to go there, edit my file, added maybe smiley face, something like that. What if we go ahead and check our status? You can see here that it still says modified log.txt.txt. What's going on? I thought we put it in the gitignore. Well, the first reason is that the gitignore isn't being tracked. Now, that's not the only reason though. There is still another reason and I'll show you why. Now, when you add your gitignore, you usually want to do it at the beginning of your project when you first add the repository, and then over time you can change it and maybe add new things that you want to ignore, things like that. So it's not really common that you would add the gitignore at the end of the project, since what's the point? You already committed everything. But that's not what we're talking about here. So let's go ahead and make some more changes to our log.txt. In theory, it should show that there's nothing here. There's no changes because it's being ignored. So let's go ahead and check the status after we changed it. And you can see it still says it's modified. So what's going on? Well, pretty much in the cache, in Git's cache, it's still sort of remembering the files instead of completely ignoring them. So what you actually have to do is fix all of these untracked files so that they are ignored and they're off the cache. So the way to do this is first to remove all of the untracked cache files. So git rm-r --cached and then dot. So this will remove all of the cached files. So you can see just like that, it's all gone. Don't worry, it doesn't remove your files. It just removes them from the remembering kind of system of Git. Now you're going to do a standard commit, adding everything. And I'm just going to say fixed file tracking. There we go. So now we did all of that. So let's go ahead and make some changes to our log. I'm going to go like that. And let's go ahead and check our Git status now. And there we go. You can see nothing happened even though we made a commit. So before I go off here, I just want to talk a little bit about the different things you can do with our thing here, our gitignore. So what I'm going to do is add a new section called auto-generated directories. Auto-generated DIRs. Now I'm going to make a new directory here called autogen. And I'm going to cd into autogen. Now I'm just going to touch a bunch of text files, just a bunch of spam. Just like that. I think 3 is enough. So let's just say these are auto-generated files, okay? So I'm gonna first commit all of them. Well, actually, I don't want to commit these, but what I want to do is commit a new gitignore. So I can edit it and I can commit this new gitignore so that we ignore these files, and we're going to use the same process as before. But I don't want to really go through and specify autogen/a.txt/b.txt. If you have 100, 1,000 auto-generated files, this gets a little bit tedious. So the easiest way to do this is just do autogen / and then star. So star will basically ignore everything inside the autogen directory. So I'm going to go ahead and save that, and now I'm going to go and commit my changes. So I'm going to say edited gitignore, just like that. There we go. Oh, whoops, I'm still in the autogen directory. Edited gitignore. There we go. We did that now. So now why don't we go ahead and change some of these files. So I'm going to go into my autogen. I'm going to edit B. I'm going to edit A, just like that. I'm going to maybe edit C as well. And now let's go ahead and see what happens when we check our status. You can see that there's nothing there. So obviously we don't really have this whole remembered system error. This is because, of course, at the beginning we edited our log.txt before we actually committed it, or before we started working on our gitignore, so it's still remembering it. But in this case, we didn't actually modify it. We added the gitignore and then we added all of the files here and edited them, so this won't work. We don't have to do this whole clearing the cache, but just remember that for the future. If you add the gitignore a little bit later, after for example, you have some auto-generated files that have already been modified and listed in the system, and then you add the gitignore, just make sure to remove them from the cache using the method I taught you in this video. All right, that's pretty much it for auto-generated files, gitignores. You can pretty much do whatever you want with these. You can put as many files, directories. You can do everything with this. A gitignore is a very useful feature, especially for much larger projects. If you're using something like an already existing engine, Unity, Unreal Engine for making games, Visual Studio, for example, creates a lot of auto-generated files. It's very useful to have a gitignore to ignore these, so that when you push it to GitHub or when you want to share it somewhere, it does it very quickly, and it doesn't take hours just uploading random gibberish that can be created instantly, pretty much. So that's just a really useful feature, and that is why gitignores, you should use them in all of your projects. All right, let's move on. So now that we're finished with the basics of Git and all of the commands that come with it, we're going to be moving on to Git branches. So this is a little bit of a more advanced topic. So let's just view a little bit about what we're going to be doing in this section. This section doesn't have that many videos, but it's completely focused on branches in Git. And the reason we're doing this is because it's such a big topic. There's a lot of things and there's a lot of moving pieces, so bundling them together with another Git section just wouldn't really make sense. So we're going to really take our time with this and make sure that we get every single piece of branches down, including theory, application, just like all the other sections about Git and the terminal even. So here's what we're going to do, and here's our game plan. First of all, we're going to cover the theory behind Git branches. So we're going to be introducing it slowly, talking about some of the uses, just going through it very slowly so you get a good, clear idea of how branches work. So we're going to be doing it just like that, and the reason we're doing this is because it's important to have some sort of an understanding of how Git branches work before we actually start using them, because they look really nice and easy in a sort of visual GUI or a picture, but once you start using it in the terminal, it gets really complex, and it's just better to have some sort of an understanding and to be comfortable with it before we move on to creating them. So after we cover the theory, like I said, we're going to move on to putting it in the real world. So we're going to learn all of the different commands and functions that come with Git branches, and we're also going to learn their uses and how you can use them in your real projects. So let's get started. So today I'm going to go over a little overview of Git branches. So I'm going to be going over what they are, how they work, and just a little bit of theory behind them so you can get comfortable with the idea of using and integrating branches into your project. So first of all, let's talk a little bit about what branches actually are. So we've all used commits in the past, and we've been using it throughout this course. We're putting it and we're taking snapshots of our project and storing them on a tree. But what a branch allows you to do is create a separate development path. And you can go off on your own and do all of that on a separate path. So let's just give a little context. Let's say we're making a project here and we want two modes. We want the bug fixing path and we want a regular development path. So let's just say theoretically that we want to sort of split them off into two because we don't want to have the bug fixing path and the release path or the master path together. So what we would do is create a branch, and then on this branch we would do all of the bug fixing commits, and you can add multiple commits to a branch, and at the end when we're done we can merge the bug fixing branch or the latest commit on the bug fixing branch with our master branch, and that will create a perfect one branch with all of the bugs fixed. And we can do this from multiple paths. I'll show you that in the next slide. But branches can be added, deleted, they can be merged, just like regular commits. So let's go to the next slide. So there's a lot of uses for branches. We have a little bit of a diagram here showing some uses for branches. So firstly, they can be used to create these separate development paths without mixing them together or overriding your older progress. On top of that, you can separate your different end goals. So for example, one branch would be used for released versions. So as you can see in that diagram there, that would be the public versions, the one that you would release for the world. And then you'd have a second branch, for example, bug fixing, and another branch for something like maybe experimenting with a new technology, and another for this and that. And at the end, you can either discard them, merge branches together. You can do all sorts of things with these branches without having to merge them together and mix them. So branches is what make Git so powerful. It's because with commits, you can do a lot, but with branches, you can really make use of Git and just expand your project to a whole new level. Now, usually you wouldn't add many branches. You'd have maybe 4 or 5 branches at max, but these branches allow you to separate your development paths and your end goals into different physical copies. So instead of merging them all together and then, for example, using comments or different files and folders to identify them, you can actually separate them into different paths. And then at the end, you can merge, for example, a new experimental technology with bug fixing, merge them together, and then merge that with the released version to make one giant public version that is dependent on a new technology. And there's just so many different things that you can do. Now, if you don't get what's going on, don't worry. We're going to go through branches in depth and we're going to cover them, and it'll make a lot more sense when we get there. But for now, let's just continue understanding what branches can do. So overall, let's just go over a little summary. Branches can be used to sort of break off of the normal commit timeline and create a series of commits on a different timeline without having to mix them up with your already existing timeline, your master branch. So you can do this to create developmental versions, bug fixes, using new technologies, maybe even refactoring your code, which is pretty much bug fixing in a sense. But you can do all sorts of things with branches, and in the end, you can move them around, you can add, delete them, you can even merge them together, just like you can do with commits. All right, let's move on. So now that we've gone over all the theory behind branches, we're going to actually start working with them in our project. So we're going to start working through them, we're going to create and delete them, and we're also going to start playing around with them, merging them, doing all sorts of things just to get a feel for branches. Now, just a disclaimer, I'm going to be creating a brand new repository because it's very hard to teach the use of branches if you're just incorporating it into an already existing project, and although it is possible, it's not very practical. So I'm going to create a new repository from scratch, and we're going to work with branches from there. So just a little note, I do have this diagram here showing how it's going to work, so how our Git project is going to look. So we have a branch which is our master branch, the release branch. So you can see here we have that. And then we have our development branch. So on the development branch is going to be adding files, modifying, and then on our release branch is going to be our major releases of our software. Now, of course, it's not a real software, but if you would have a real software, it would look like this. So you'd have version 1.0, 1.1, things like that, all the way until your final release. And of course, we could make this more complex with bug fixes, things like that. We could do all sorts of things, but we're not going to do that now. We're going to leave that for some other time. But for now, we're just trying to learn about branches and just get a feel for them. So we're not really trying to mess around with some of the more complex features of branches, you know, making multiple branches, sub branches, things like that. We're just going to leave it to the simple bare bones. So let's get started. I'm going to open up my Ubuntu terminal and I'm going to cd into my path. Now I'm going to go back one since we're creating a new project, and I'm going to make a new directory called my new software. There we go. So let's cd into it. Whoops. cd my new software. There we go. So let's get started. First thing I want to do is create or initialize an empty Git repository. So I'm going to do git init. Now I'm going to make a few folders, maybe go into them, make a few files. And you see why I'm using the terminal instead of using something like a GUI. It's because it's just much quicker to create these mass files such as this. So file.txt, touch script.js, cd ... So you can see how it just becomes much faster. Or sorry, not make directory, touch lib.py. We're doing all sorts of things. So I'm just setting up the file structure now. Okay, there we go. So we have the basics here set up, and now we're going to start working on creating and moving between our branches. So first thing I want to do is just check the status, see what we have here. We have a bunch of files that are untracked, so I'm going to git add dot, and then I'm going to make a new commit called initial commit. Now remember, you have to make an initial commit before you actually start working on creating branches. Otherwise, your development branch is going to be considered your master branch, and you don't want that to happen since we're trying to consider our release branch our master, as shown in our picture here. I'm actually just going to put that off to the side so that we can take a good look at it while we're working. All right, let's get started. So first thing I want to do is start working on creating a new branch. So there are different ways of creating a branch. The first one is git branch and then the name of the branch. So git branch, whoops. And then you would put the name of the branch here. But the way that I'm going to use is git checkout -b and then the name of the branch. Because what that does is not only does it create a new branch, it also switches to it. So I'm just going to call it dev for development. And we're going to do that. And there you go. It says switched to a new branch there. So there we go. We have it right like that. Now we don't actually have our commit yet. We just developed the branch, but we haven't connected them just yet. We still need to work a little bit on creating commits and things like that, but we'll do that in the next video. For now, we've created our branch and that's good. But now I want to switch back to our older branch. So our master branch, our release branch. What you would do is just git checkout master. And there you go. Now we're back on our master branch. And if I actually open it up in my folders, of course you won't see any visual difference because it's all the same. We haven't actually made any commits yet. But there we go. We've created a branch. Now what I'm going to do is just create a new branch. I'm going to call it git branch and then I'm going to call it bugs. So what that's going to do is create a new branch called bugs. There we go. Now if I want to list all of my current branches, I can use git branch -a for all, and that is going to list all of the branches that we currently have. So the star signifies the branch that you're currently on. So in this case, it's master. If I actually go and check out something like bugs, like that, and if I go and git branch -a, it's going to show that I'm on the bugs branch. So I'm going to go back to my master branch. Now, what if I wanted to delete a branch? So For example, maybe I didn't find a use for it. I don't really need it anymore. How am I supposed to remove it? So it's actually quite easy to remove branches. All you have to do is git branch -d, and then you would specify the name of the branch. So in this case, I want to delete bugs. So it says it deleted branch bugs was B94, B942. It's actually quite a nice ID. But let's not worry about that for now. Let's list all of the branches. There we go. So now we only have 2 of them. So the reason I wanted to sort of show you or go through this quite quick is because we've already looked at all of the different commands, and I'm sure you've realized that it's quite easy to pick up commands here and there. And on top of that, you don't really need to memorize them. The whole point of this is to understand the concepts behind them. So we've learned how to create branches and delete them, move between them now. But now that we've created these branches and we can work with them, we want to actually start putting commits on the branches so that we can actually integrate them into our workflow. All right, let's move on. So now that we've learned how to add, create, and move between branches, we're going to start working on adding commits to these branches, because right now this structure isn't really followed, at least up till here. So what we're going to do is go through and create this section. So we're not going to work on this just yet. Merging we'll do in the next video. For now, we're just going to start adding commits to this branch right here. So how are we going to do this? Well, the first thing you're going to need to do is actually switch to your other branch. So I'm going to switch to Git Checkout Dev. So at this point, you would have switched to your development branch, which means you're now working on creating the next version or version 1 of your software. Now, of course, in reality, this might take months or weeks or months or however big your project is. But in our case, we're just going to create a few sample commits and pretend that we're creating some software. So what I'm going to do is go and open up some files here in my new software, open up file 2, some text. I'm going to save that, just create some dummy commits, git add dot and git commit -m. So you can see here that I'm creating commits in just a normal fashion, because what's happening is we're talking about branch view here. And it might seem like you have to do some special commands and things, maybe specify the branch in your commit, but you don't have to do any of that, because right now we are on the development branch, and just like before, we were on the master branch. So nothing's really changing except the branch that we're on. So all of the same rules still apply. You can still check out, you can still revert. It's just on a different branch. So you've kind of created a diversion from your master branch. It's kind of making it multi-dimensional in a sense. It just adds a little bit more complexity, so don't really worry about it. All of the commands are the same. Just think of it, you're on a separate path to a different goal, for example. So we're just going to make a normal commit. Let's just say dummy commit. So it doesn't really matter what you put here, but if you're working on real software, what you would be doing at this point is working on, let's say, maybe develop new function, then bug, or well, not bug fixes, but refactored, and then you would say final fixes, then added new function. You would do all sorts of things, just developing towards the first version of your product. And this is coming back to what I was saying about some of the uses of Git. It allows you to organize the complexity of your projects into something that's a little bit more manageable. You have tangible goals that you can reach. This is used by software developers all over the world, and including enterprise projects and project managers. They use this because it allows you to break up your work and set smart goals that you can actually reach, instead of having one giant big goal at the end where it's some imaginary thing that you're going to reach in a few years. So that's just one use. And now I'm starting to prove to you, hopefully, that this is one of the big uses of Git and how branches can help us majorly. All right, so enough talking. Let's go through and finish off some of these commits. So I'm going to say more text maybe, and I'm going to go and add another dummy commit. Dummy commit 2. Oh, whoops, forgot to add actually. Always remember to add your files. There we go. Dummy commit 2. All right, there we go. We created our second dummy commit. So why don't we check out our log here? You can see that we have our initial commit, and then we have commit, dummy commit and dummy commit 2, but you can see that there's no real visualization like there is here. You can see here we have, created a branch and then the commits and all of that, but here we don't have any of that. That's the thing. And that's a big problem because we can't really differentiate between the branches. So this is where you need to keep in your mind that, make sure that you know which branch you're on, which commits you're making. This is why I like to say, be very careful with what you add and commit, because, sometimes you can commit the wrong thing and it's going to be a nightmare to get it out. So just be careful and be cautious when you're doing it. Don't try and rush too fast. So there we go. We created some dummy commits. Now that's really all I wanted to talk about in this video, because what I'm basically talking about here is just creating commits on branches. And you can see that there's really not much of a difference between this branch or the master branch or any branch for that matter. But what is the difference, and what does make the big difference, is merging branches, which we're going to cover in the next video. So that is quite a complex topic. I'm going to go through it thoroughly so you know how to do it. And yeah, so we're done with editing our branches. In the next video, we're going to merge our commits from the development branch onto version 1.0 of our master branch. All right, let's go. So this is going to be the final video in the section about branches. We've kind of messed around with all of the different features that we can do with branches, but now we're going to bring it all together and start working on merging. So without merging, branches are kind of useless. They don't really work well. They're just floating strings in the middle of a Git repository. They can't really be connected together, but with merging, you can bring it all together and really open up the power of Git. So this is probably one of the most important topics in all of Git, is merging branches together. So let's get started. Now the first thing I want to do is just tell you about the different commands that you can use to merge. There are two different commands. The first one allows you to merge a branch into the current branch that you're on. So let's say I'm on the master branch, I can merge the developer branch into the master branch. The second version is merging a source branch into a target branch, regardless of whichever branch you're on. So for example, let's say I had a bug fix branch, I could merge that one into the development branch, and it doesn't really matter which branch I was on. For example, master, because again, it's merging into the target branch and not the current branch that you're on. So I'm going to be using the first one today. So what we're going to do first is go into our developer or development branch. It seems I'm already on there, and just add a version file like this, which says the I just added a version file like this that says the current version of the software. So now I'm going to check my status, git add dot, and then I'm going to commit it saying release version 1.0. There we go. So I've committed that on the development branch. Now let's switch over to our master branch, and we're gonna merge them together. So first let's check if making sure that our working directory is clean. We don't have any files we need to commit. So there we go, we're ready for it. So we do git merge and the name of the branch that you want to merge into your current branch. Do that, and there we go. That's all you have to do. It's as simple as that. Let's go ahead and check the log, and you can see that we have initial commit and then dummy commit 2, and then release version 1.0. And you can see it says head, master, and dev. So the two branches are merged together on this release 1.0 commit right here. So if I check out any other commit, let's just say dummy commit 2, git checkout, like that. And if I log, you can see that our head, it doesn't really show it doesn't show that we're on dev, it doesn't show that we're on master, because right now, this is what happened. At one point, this was the top level or the tip of the branch. It would show head and then an arrow pointing to dev. But then we merged it, and now it's on version 1.0. So now we're here on another branch. So this is where we are right now. We're on version 1.0. So from here, you can pretty much do whatever you want. I'm just gonna change back to my master branch. So now you can pretty much do whatever you want from here. You can go ahead and go back onto your development branch and create another commit, which is going to kind of mimic this scenario right here. You can pretty much do whatever you want from here. It's completely up to you. But right now we're pretty much done with merging. It was very, very simple. It doesn't really require a lot of effort. And yeah, that's pretty much it for merging. Now, if you want to know more about merging, or if you want to find out some other things, I've linked some resources in the lecture content. So because merging is such a big topic, it's really too much to cover in one video. So I've linked some resources that you can go and check out on your own time, maybe after the video, and that'll give you a better idea of merging if you're still unclear. But yeah, that's pretty much it. So that's what merging is. You can merge branches together, you can add them, you can delete them, you can do all sorts of stuff with them. But the main thing you need to take away here is branches are what make Git one of the most powerful version control softwares out of all the version controls. It makes it just such a powerful tool to use because it allows you to, again, manage complexity exponentially better than any other version control software. So that's just one thing you need to take away from this. But yeah, there you go. So we've merged the branches together, we have everything set up, and now that we've learned most of the basics of Git, we're going to move on to learn about GitHub. All right, let's move on. So now we're going to start moving into GitHub. So this is going to be really interesting. There's a lot of new features we're going to be using in this section. So let's get started with some introduction. So here's a little overview of what's going to happen. So we're going to look at GitHub mainly, and what it is, what it can be used for, and mainly how to use it, because it's a little bit of a learning curve at first if you don't know what's going on. So we're going to be creating a GitHub account, and I'm going to walk you through step by step on all of the different things you can do. Forking, pull requests, downloading, all sorts of things. There's many, many different things you can do on GitHub. On top of that, we're going to be creating our own repository and working with that. In just a second. So before that, we're going to look at some of the history behind GitHub, what it is and some of its main purposes, and we're going to look at the benefits of using GitHub and why it's so widely used today. Because right now it's an industry standard in software development, and it's kind of like a necessity for all software developers. So let's move forward to using GitHub. After we give an introduction, we're going to start moving into actually using it. So this is where we make an account, we go make our own repository, try to upkeep it, and do other things with other people's repositories. And obviously not random ones, there are specific ones for these purposes, but that's not the point. We'll get into that later. We're going to be messing around with all of these repositories and just playing around with them, seeing if we can maybe clone them and then edit our clone, and we're going to be doing all sorts of stuff with GitHub. So the main point of this is to try and get a little bit familiar with GitHub's platform, and because once we do that, you understood most of the course. And once you can use Git and GitHub together using the small amount of commands that connect them, you can use them interchangeably, and that's when they get really powerful together. It's because Git is already such a powerful tool, but with GitHub, you can turn your project into anything you want. The things that you can do with Git and GitHub is limitless, because not only can you work with other people, but you can also do things with the repository that you cannot necessarily do with Git. So let's get straight into GitHub and start creating and managing some repositories. So in this video, I'm going to be giving a quick introduction to GitHub. I'm going to talk a little bit about what it is, how it works, and some of the benefits that come with it. So firstly, and most importantly, let's give a quick introduction to the motives behind GitHub. So GitHub is, at its core, something that allows you to store your repositories on shared servers, on GitHub's shared servers. So it allows you to turn your local repositories into a remote repository. Now, obviously, anyone can create something like that, but what really sets GitHub apart is it gives you all of these opportunities and benefits and tools to interact with your repository in a user-friendly way. It's public. GitHub is a public platform, which allows millions of users to share their projects to the world and interact with them in a user-friendly manner. So that's what GitHub is at its core. So why use GitHub? So I have a little picture here. from GitHub saying social coding. This is almost like their motto. This is what they follow. You can see that the GitHub is built around collaboration in development. So that's the main purpose of GitHub, is to allow people to collaborate together to build projects. But it's not just for collaboration. On top of that, GitHub is used, or can be used, as a portfolio for your best work. When you're trying to get a developer job, you can supply your resume, but along with your resume, they're probably going to ask you for some sort of portfolio of your best work. All you have to do is send them your GitHub account link, and they can view all of your commits, your contributions, your projects. It's that easy. So this is what makes GitHub so powerful and so versatile, is you can use it for almost anything in this sense, in the developer sense. You can use it as a portfolio for your best work, or you can use it as a company, as sort of team manager to allow people to collaborate together. But on top of that, and one of the most useful features of GitHub is being able to access your repository from any location. So think of it this way. On your local machine, you can only access it from that machine. And let's just say you wanted to maybe transfer it to your laptop or use it on your laptop because you're going away on a business trip. So what you would have to do is get a USB, you'd have to transfer all the files, you'd have to put it on your laptop, and then all of the changes that you made, you'd have to put it back on the USB and back on the device that you were originally making it on to update it and sync it together. You can see how tedious that process gets. It's tiring just for me to say. With GitHub, you can interact with one repository back and forth from any device, and it updates centrally. So, for example, let's just say I wanted to make some changes to my repository while I was on a trip from my laptop. All I could do is pull it from the repository on GitHub, make my changes, push it back, and then there you go. That's all you have to do. When I get back, all I have to do is update it by pulling the new information, and that's it. No USBs, no transfers, syncing, all of that is disappeared with the use of remote repositories. So the final reason is because it's an industry standard for hosting Git repositories. Now, there are other smaller sites out there that can do this, but because GitHub is used by almost every developer company in the world, it's become an industry standard. And that's why it's very useful to know GitHub and how to use it, because without it, it's a little bit hard to collaborate on teams. And not just that, it gets very hard to manage your repository. So GitHub is what brings Git together and makes it such a powerful tool. It just builds on it and makes it even better than it already is. All right, let's get started. So in this video, we are going to be creating our GitHub account. So this is quite an easy step. I just want to walk you through so that you can get familiar with the GitHub homepage and just getting used to things. So what you want to do first is go and open up Google or whatever browser you're using, and you're just going to go to github.com. So once you're there, it's going to take you to the GitHub homepage, and you're going to sign up for GitHub using your username, your email, your password. So I'm just going to quickly go and fill this out now. Okay, so once you've filled out your information, you can see here it says verify account. So then you're just going to click on creating account, and it's just going to create that account for you. So let's just wait for that to load. There you go. So now you can choose your plan. So you can see here it says unlimited public repositories for free, unlimited private repositories for $7 a month. So we're just going to go with unlimited public repos for free. If you want to sign up for GitHub Pro, if you want private repos, you can go ahead and do that. But it doesn't really matter. I prefer to just, if it's something really sensitive and if you want to keep it a secret, go ahead and buy some private repos, or even better, don't put it on GitHub at all if it's that sensitive. But it's better to just use public repositories and block any access. So that's what I'm going to do. So now you have help me set up an organization next. We're not going to do that. And then we have some mailing lists. We're not going to do that either. So we're just going to click continue. And now you're going to just fill out this field. So you can go put totally new to programming, someone experienced, very experienced. I'm just going to put totally new to programming to sort of see what kind of happens. If you can put whatever your experience level is. My personal account is here. So if you have had a lot of experience with programming, you can put it there. Just choose whatever you want. It won't make that much of a difference. So what do you plan to use GitHub for? Right now, I'm just going to put project management and development. You can put whatever you want here. depending on your needs. Which is the closest to how you would describe yourself? I'm a hobbyist, I'm a student, or I'm a professional. I'm just going to put I'm a student. So what are you interested in? You can put the kind of, the topics that you kind of like. So you can see there's a lot of different topics here. You can put, let's just say Python, Python, JavaScript. It's kind of like a tag system. So we're just going to put those two. Web development maybe? Oh, hold on. Web-development. Web-development. You can put your personal interests here based on whatever you want. There you go. So now I've created my repository, my account, and now I have a fresh GitHub account. So there we go. Now I'm just going to take you through the stuff that you can see on your page. So you can see learn Git and GitHub without any code. This is just a quick guide, but I'm sure you don't need that, especially because you're watching this course. You can see your repositories here. We don't have any. We're going to create one in the next video. You have some activity feeds. If you're following or collaborating on any projects, you can do that. We're going to explore GitHub also in the later videos. So if you click the drop down here, you can go to your profile, your repositories, things like that. And it says here, 1 contribution in the last year. Pretty much what's happening is every time you make a commit or create a new repository or contribute, you get a contribution. So this allows people to see what's going on. You can add a bio here. I'm just going to tick that off. You can add a bio. Your repositories is going to show all the repositories you have here that are public. Okay, so starred repositories are pretty much repositories that you want to keep or you want to frequently look at. So stars are pretty cool in terms of when you create repositories and people star it, that means they're using it or they're looking at it. It's a pretty rewarding feeling to get many, like over 3 figures of stars. But let's look at followers and following now. So followers, anyone who's following your account, and of course you have following. Pretty self-explanatory. So you can edit your profile if you want. I'm not going to go through and do that now since this is sort of a tutorial account. There's a few other things you can do, your stars, your gists. We're not really going to go through everything on here now, but we're kind of getting to look at some of the other features of GitHub because right now we don't really need to manage our profile. That's pretty self-explanatory and it's just like any other social media account. But pretty much what we're looking at doing is managing repositories and working with repositories, the cool and the core features of GitHub. So we're going to work with those in the next few videos. But for now, we've set up our GitHub account, so let's move on. So now that we've created our GitHub account, we're going to work on creating our first repository. So this is where the good core components come in and we start using GitHub and all of the features that come with it. So we're going to be creating our first repository in this video. So what you want to do is, one of the ways of creating a repository is go into your home page, then you're going to go to repositories and then new repository. This is going to take you to the repository creation wizard. So first up here, you're going to put the name of the repo. So I'm going to put my repo just as a little trial. And then under the description, you're just going to put a short summary of what your software project or application is about. So I'm going to say a test repository for learning GitHub. There we go. So now you can choose private or public. Now, unfortunately, you cannot choose private unless you have the paid plan, but I'm just going to go with public for now. You can still choose who can commit to the project, but for now, we're just going to keep it on public. Now, if you have the paid version and you want to use private, by all means, go ahead. Now, for now, we're going to be initializing this repository with a README. So we're going to, work with all of that. But in the future, when we start working with remote Git commands, we are actually going to create empty repositories. So we can't really do all this README and all of this stuff like this. But for now, we're going to keep it on. So now you can choose to add a git ignore. Now these are template git ignores. So you can choose from the template here if you're using something specific. For now, we're just going to leave the git ignore off, and then you can add a license. So you can read about licenses all over the place. There's many different licenses for different things. For now, I'm just going to choose MIT license because this is the license that allows people to freely distribute it and copy it however they want. So it doesn't really matter which license we choose for now since we're not putting anything on here. But if you're putting some software for a business or a company, then you're probably going to want to use some other license that prevents people from copying and distributing your work. So let's go ahead and create this repository. So there we go. This is what a repository looks like. There's a bunch of things here that we can see. First of all is the number of total commits. Then we have the number of branches, the number of releases, contributors, and the license. So right here you can see the file structure. If there is more files, you'd see a bunch of different files. In the README, the README will show, well, pretty much the README. So in there you can put, maybe something like a summary about your repository or project, all sorts of things like that. We're not going to get into writing a README now. You can do that in your own time since this is a test repository. But let's go over some of the other things we can see here. There's a bunch of tabs. So we're going to talk about these features when we view other people's repositories. We'll do that later in the course, but let's view some of these right here. So issues. So issues can be labeled by contributors. Anyone who's listening on your project, working on it, can actually find an issue and list it. And what you can do, or what PU and other contributors can do, is go and look through and find these issues and try and fix them. So it's a really useful feature on GitHub. And that's what I was saying. GitHub is all about socializing with other developers and, just bringing everyone together as a community. So now we have pull requests. So I was talking a lot about the push-pull cycle, but pull requests are basically anyone who is requesting access to pull your project onto their local machine. So that's pretty much what a pull request is. Now you have projects here. So this is just a little thing. Let's read it here. Do you know you can manage projects in the same place you keep your code? We don't really need to go through all of this because this is just a bunch of workflow management. So we're not going to use this for now. On the wiki, you can actually, is a bigger place to lay out something like a summary. So pretty much we have the README, which is just a short kind of quick and concise place to list your project. But on the wiki, you can list maybe a documentation. So this would be a great place to put a documentation of one of your maybe applications, libraries, things like that. You would put it in the wiki. So Insights allows you to see a lot of different features about your repository. So pretty much just like Google Analytics or any other analytics program. So right here you can see merged pull requests, proposed pull requests. There's a bunch of different metrics here. We're not going to go through them. You can look at some of your contributions for different contributors. There's a bunch of stuff here that you can go through in your own time. We don't really need to look at analytics for now. But just go through, read everything. It's pretty short introductions. Don't worry about this. So let's move on to settings. There we go. So in settings, we can change some of the things about our repository. So if you want, you can delete your repository from there, but I wouldn't recommend deleting repositories at all. That's a very, very dangerous move. So try and, unless you are absolutely sure you want to delete it, don't go through and try and delete repositories. So there you go. You can change the name here if you want. I wouldn't recommend that though. So once you have a name and once it's established and you're using it all over the place, try not to change it that much. So you have features here. You have wikis. So this is just a bunch of enabling different things and allowing people to do things. So like I said, you have your collaborators. You can invite collaborators from here. So, maybe invite your team, whoever you're working with. You have your branches, and you can switch between the default branch and other branches. Webhooks allows you to integrate GitHub into your web application. So for example, when a pull request happens, it does something on a web application. So that's pretty much what it is. You can read about that in your own time, but I'm not going to go through it now. So integrations and services, you can see it's being deprecated. So we're not really going to go through that, but this just works. It basically works the same as webhooks in a way, and it just has a bunch of different things that you can integrate into your applications. You have your deploy keys. We're not going to be using these. And like I said, deploy keys in the beginning, I said I was talking about other programs and other software that has integration with Git and GitHub. So like Heroku. So Heroku would need a GitHub key to actually deploy something onto their server. So that's what deploy keys are used for. Then we have interaction limits. So this is just changing the sort of access that users and contributors can have. So you can enable these if you want. I'm just going to leave them all off. And that's pretty much it. We have gone through all of the different things in our repository. So we have a few things here, but like I said, we're going to leave a lot of these interactive features for interacting with other repositories. So we're going to leave it for that and just go through, interact with your repository, look at some of the features I skipped over maybe, if you're interested in them. I don't think it's necessary for the course, or for the most part, it's not really necessary, but if you're really interested in it, go ahead, take a look at it. It really shouldn't take that long to learn. So yeah, that's pretty much it for our repository. In the next few videos, we're going to be working towards working with all of our actual features and everything like that. So we're going to work through messing with other people's repositories, mostly test repositories from GitHub. We're going to do all sorts of stuff and really interact with repositories and get the most out of GitHub. All right, let's move on. So in this video, we are going to be exploring some other repositories. So I'm going to go through and just work with some repositories, look at them, try and interact with some of the features so that you can get used to looking at other repositories, because more often than not in your development careers, you might need something, a piece of code, some project, some form of automation that will take way too long to write yourself. So what you would do is go on GitHub, search for some automation software, whatever you're looking for, fork it or clone it or download it. All three of them, we'll talk about them in this video, in the next few videos, and then integrate it into your program. So that's what I'm going to be teaching you how to do today. So first of all, wherever you are, there's going to be this little search bar up here. So you can search for pretty much whatever you want. Now, the one that I'm going to be using, or the repository, is called spoon-knife. It's a demonstration repository. But you can search for pretty much whatever you want. So if I wanted to search for some deep learning, I could search deep learning, or whatever you're looking for, something specific. You can see there's a bunch of deep learning repositories here. But what we're looking for is called spoon-knife. So I'm going to look for it. And there you go. You can just look through and find the one that you have. And by the way, these are the number of stars. So people who are looking at the repository or, currently favorited it. You have a language here. Usually these are, not all of them are declared, but you can see that the language is here. We have 45 HTML, we have some CSS, some Java. There's a bunch here. So let's open up octocat/spoon-knife. So you can see that this looks a lot more lively than our repository. Of course, it has 3 commits, 3 branches, 0 releases, and 1 contributor. So you can see there's over 5,000 pull requests. So there is a lot of pull requests here. You can see create tutorial, added my username to index, sample pull request. There's a bunch here, and we're actually going to be making a pull request later in this course. But we're not going to do it now. Right now, what we're trying to do is look at some of the other stuff we have here. So let's look at some of the features that we can use with this. So we can watch it. Pretty much we can just, watching is not the same as starring, by the way. Watching will pretty much just notify you if there's new conversations, new commits, anything like that. Any big updates, what will happen is you will be notified. So you're pretty much getting in on the spoon-knife community. It's not a big community, and I'll show you the biggest community on GitHub in just a second. But for now, I'm just going to unwatch it. You can star the program, or the repository, and pretty much what this does it favorites it. It allows you to go and view it, interact with it. It's sort of like a hotkey. You can easily get to it very quickly. Then you have fork, which is pretty much going to take a piece or a copy of this repository and put it in your account. So a lot of people fork this because what's happening is this is called spoon-knife. This is a demonstration for people to fork and try and take this repository and put it in their own. So this is kind of like a training repository for forking. So what you can do is just go and click on fork, and what that's going to do is take a copy of this and put it directly in your account. So I'm just going to fork it. So now we forked it, and I'll show you what that did in just a second, but there's a few things that we have here. What we can do is create a new file, upload files, and find file. But that's weird. Isn't that not our account? Well, look up here. It says forked from Octocat/Spoon Knife. So this is actually in our account. And if I go over to my profile and look at my repositories, where is it? Just looking for it. Yeah, Spoon Knife right there, popular repositories. You can see forked from Octocat/Spoon Knife. So let's go ahead and open that. And you can see that we can create files and mess around with this. So forking is a really good way of interacting with someone else's repository without actually having to damage it or work with it or ask for some sort of pull request. So this is what we're going to do. We're going to try and interact with Spoon Knife, the repository, from the original in some other ways, such as cloning or downloading. Then I'm going to explain the differences between forking, cloning, and downloading. So let's go back to the original repository. Let's go ahead and try and download this. So it says clone with HTTPS. And what this is going to do is pretty much take all of the information and put it in a local repository. Or you can download it as a zip, which is just going to give you the entire directory directly. So those are the differences. Forking pretty much takes that repository and puts it on GitHub. From there, you can interact with it through Git. You can push and pull because it's yours now. This is probably one of the most common ways of cloning a repository because it still involves GitHub. Now, cloning is pretty much taking a link and then using it to take all of the information and make a copy of it on your local machine. This has nothing to do with GitHub, and although you can push it to GitHub later on, it's really hard to push a project to GitHub after it's been fully developed. There's a lot of conflictions, and it's just very difficult. On the other hand, downloading just takes the entire directory, packages it up in a zip, and downloads it. So that's the difference between cloning, forking, and downloading. I would recommend if you want to play around with someone's own project, you can use fork. It's probably the best way of interacting with someone's project. But if you really want to download it and, try and get a feel for it on your own OS, you can totally do that. But still, I would recommend forking it because even after putting it on GitHub, you can still interact with it and you still get all of the benefits of using GitHub. Alright, so that's pretty much viewing other people's repositories. It's quite simple actually to view and manage and play around with other people's repositories. There's not much of a difference between it and managing your own. But yeah, that's pretty much it. So you can go through and look at repositories that you may like if you have somewhat of a development background. You can go and search for projects that you may like, maybe related to Python or Java or whatever language you use or whatever libraries you work in. So you can go and do that. Just go ahead, look around for people's projects and try and see what you can do with it. Maybe fork it, and if you have experience in that topic, go ahead and play around with it, see what you can do. It's quite fun just to go around and play with people's repositories. And I enjoy it, and I do it as a pastime as well. Also, it's a good way to sharpen your skills if you're a little bit rusty on something. Alright, so that's pretty much it for viewing other people's repositories, and let's move on. So in this video, I'm going to be talking about downloading repositories. Now, I don't mean cloning, I don't mean forking, because we're going to save that for the next section. What I mean is actually downloading it. So I'm just going to go through, download this repository, the Spoon Knife repository, and I'm going to be showing you how to interact with it on your desktop. So first thing you want to do is go ahead and head over to the repository you want to download. Make sure that if you're going to distribute it, it's under an MIT license or something similar. So you're just going to go here and click on it and click download zip. Now what that's going to do is collect everything and put it in your downloads. So now what I'm going to do is go ahead and open it in my GUI, because I'm not going to go through extracting things from zip files in the terminal. I'm not going to go through that yet, but I'm just going to find it here. So what you're going to do is go ahead and extract all. There you go. So now I have the folder open. So what I'm going to do is actually go ahead and drag this into my folders. And then in my folders, I'm going to drag it into my projects. So now what I'm going to do is go and just open up my path for my terminal. So I don't have to go and copy all of that again. So I'm just going to copy that. Open up in Ubuntu terminal. And I'm going to just close all this down so it's a little bit easier to see. So then I'm going to cd into that, cd.ls. Now there we go, we have spoon knife master. So let's cd into that. So now let's list everything. You can see there's a lot of stuff here. Why don't we go ahead and check the git status, see what we get. You can see it says fatal, not a Git repository. So this is a little bit weird. What's going on? When you pretty much what happens is when you download Git repositories, I'm just going to open up the repository here. When you download it, what you're actually doing is collecting everything and putting the source files in here. It doesn't get any of the Git files. Let me show you what I mean. If we go into projects, my new software, there's .git. If we go into my software, there's .git. If we go into spoon knife master, we don't see anything there. So this is why I recommend against downloading by zip. What I recommend is if you want to clone it, use HTTPS or SSH or whatever other method you want. Clone it, don't download it, because when you download it, what you're doing is taking the source files. And sure, that might be useful if you just want to tinker around with it, but if you're trying to integrate it into your project or somehow look at the history like I am, it's not really useful because all of the Git history and branches and all of that is gone. So we're not going to go over cloning or forking or pull requests now. I mean, we have gone over forking, but forking into your local repository, we're not going to go over that now. We're saving that for the next section where we bring Git and GitHub together. But just know that, just wanted to make a little update video telling you that if you're trying to download by zip and it's not working, giving you Git status or Git log or whatever you're trying to do and it's not working, that's why. So that's pretty much it for this video. Let's move on. So this is towards the end of the course where we learn Git, we learn GitHub. So what do we do now? Well, now we're going to bring our skills together to really make the most out of Git and GitHub. So let's get started. Basically, in this section, we're going to be bringing our Git and GitHub skills together to take our project live or to the real world. So we're going to be learning a lot of new commands in Git as well. So it's not just theory and learning presentations and all of that. What we're actually going to do is learn different commands that we can use to work with GitHub, and not just GitHub, but bring our project to shared servers and remote servers, which is something we haven't learned to do yet. And it's also why in the past I've held off forking or pull requests, because I wanted to save it for this section when we had a good background in both Git and GitHub. So we're in the start of this section, we're going to learn some of the terminology that we need to use in the section. So things like pull requests, push-pull cycle, remote repositories, things like that. We're going to learn everything about them, and we're just going to learn how to use them and just get comfortable with these terms so that when we move on to the practical part, we can really get started and not have any troubles getting everything online. So then in the application part of the section, like I said, we're going to use Git and GitHub at the same time for the first time. This is going to be the first time in the course where we use Git and GitHub together, and it's going to be really exciting. It's one of my favorite parts of this course, and I've been really looking forward to it. So we're going to learn all of the codes and commands that we can use to access remote servers and remote areas and data centers with Git. And we're going to learn all of the ways we can do this through HTTPS, SSH. We're going to learn all of that. And then we're going to learn some of the techniques we can use to manage a remote repository. So push-pull cycles, things like that. We're going to learn how to manage it in this section so that when you get to the real world and you start developing, you can manage your repositories and work on your projects from anywhere on any device. All right, let's get started. So in this video, we are going to be creating a brand new remote repository in GitHub, and then we're going to be working with it throughout the next few videos. So the first thing I want to do is talk about how we actually create a remote repository. So in the past, when we've created repositories, we've gone onto our terminal, made a new directory, and then did git init to create a new repository. However, in this lecture, it's a little bit different. Because we're creating it remotely, we're going to need to do it through GitHub and then run some terminal commands to actually connect to it through our local machine. So let's get started. First thing you want to do is go over to GitHub and open up your account wherever you are. And now we're just going to create a brand new repository. So this can be for whatever project you want, but in this case, I'm creating a new repository so that I can actually work with it throughout the next few videos. So I'm just going to call this my new repo, like that. A repository created to learn connecting to GitHub remotely. Okay, we're just going to leave it at that. Now here's the important part. You don't want to create a README, you don't want to add any gitignore, and you don't want to add any licenses. Just make a brand new blank repository. The reason that we're doing this is because when we actually connect to it through GitHub, what's going to happen is we're going to create all of those things. So we can create READMEs, licenses, and on top of that, we can create it through GitHub later after we've connected. So just keep that in mind. If you create these things, it might cause some errors when you're pushing it and pulling it. We'll do those in the later videos, but for now, just create it and make sure it's blank. So we're going to create that repository. There you go. So now we have a repository set up. No code, no READMEs, and no licenses. This is exactly where we want to be right now. So now that we've done that, let's just go onto my desktop, and what I'm going to do is first copy the path to the terminal, as I always do at the beginning of a section. So I'm going to copy this and I'm going to make a new directory on my local machine. So I'm going to open up my terminal, just like that. So then I'm going to cd, just erase all that. So I'm going to cd into our folder there. I'm going to go back a level. And I'm going to make a new directory and just call it my or git remote connection or con, just like that. Make it short, sweet, so that we can easily access it. There we go. So I'm going to cd into it. All right, there we go. So it's working now. So now that we did that, we need to start actually connecting to it through our terminal. So what we're going to do first is go and get this URL here. So it's either HTTPS or SSH. I would recommend just going with HTTPS since it's pretty much almost the same thing. I just prefer to use it. It's a little bit easier. So first thing I want to do, copy that link. Next thing I want to do is go back into my terminal and I'm going to first initialize a new repository, just like that. There we go. So now that we've initialized the new repository, we need to actually connect to it through our terminal. So this is a little bit complicated in a way, but it's not the worst thing that can happen. So basically what's going on here is we're going to add something called an origin to the GitHub repository through our terminal, and it's going to allow us to connect through the local repository to the remote repository. So this is what you have to do. Git remote add origin, and then you want to paste in the URL that you got from your GitHub repository. So you're just going to click enter, and there you go. So now pretty much what happened is we connected our GitHub repository with our Git repository. So they're both empty, there's nothing in them, but in the next few videos we're going to be working towards adding commits and pushing and pulling so that we can actually start to use them together. And if you want to check if it works and if you connect it properly, all you have to do is type git remote -v. And if it shows you here your GitHub repository fetch and push, which is similar to the push and pull system, then it's all connected and you're ready to start working on your commits and making everything work together. So you can also do this through the SSH URL, but it'll require a few extra steps. Just make sure that you know what you're doing there. So you can see also down here, we have a few steps right here. So for example, it says here, here it just creates the README, and then you create a new repository and then add this and commit it and do all of that. We're going to be doing that in the next few videos, so don't worry about that. But for now, we just connected our repositories. So in the next few videos, we're going to work towards pushing, pulling, creating our readmes, our commits, things like that. All right, let's move on. So in this video, I'm going to be talking about the push and pull system. Now, I've already gone through all of the setting up your repository, connecting it to your repository here. We already went through all of that. But what we're going to be doing in this video is I'm going to be explaining to you how the push and pull system works. So in the last video, you can see here I still have the terminal open. We added a remote origin, which basically allows us to connect to our GitHub repository. You can see just like that, fetch and push. So now what we're going to do is actually talk about what that means, what fetch means and what push means and the origin, and we're going to talk about all of that in this video. So on my desktop here, I have the Git workflow diagram back open right here. So you don't need to worry about any of this part. We already went through all of that, learned how to do it. But what you really need to focus on now is these two, the local and remote repository and the links between them. So what are these arrows here? Basically what this is saying is there's a cycle. You can push and pull from a remote repository, kind of like a loop. So for example, you take all the information from a remote repository, you make changes onto it on your local machine, and then you push it and update the remote repository with the changes you've made. And you keep doing that in a cycle until you're done. So this is pretty much what we're trying to explain and do over the next few videos, is push to a remote repository, pull from it. We're trying to fetch information, do all of that. And for now, I just want to explain how all of this works. So when we typed git remote add origin here, what this basically did is told our repository that what's happening is we created a new remote repository at this URL. And this opens us to a whole lot of new opportunities with Git. So you can see here when you do git remote -v, it gives us these two links here, fetch and push. So fetch is pretty much pull. What this is saying is when we run a command, which we're going to introduce later, we're going to take information from this repository here on GitHub, which is the one we just created. And for example, let's just say that I want to pull some information from a repository that's not mine. Let's just say from the Linux repository. Now, I know there's issues with that and you're not actually allowed to pull from the Linux repository, but let's just say, for example, here. So if you go on GitHub right now and you search Linux, you're going to find the GitHub repo for Linux. I'm actually going to search it right here. Hold on. You have to make sure to search in all of GitHub and not just in your repository, because if you search here, you're just going to find Linux, or where you can find it in your repository. So right here, you can see this is the Linux source kernel. So right here, it has almost 783,000 commits. It's a lot of commits. But you can see that it says right here, pull request. So what does this mean? Pretty much what's happening is all of these people are asking to pull information from the Linux kernel onto their local machines. Now, it's not just necessarily the local machines. There could be many different ways you can pull to, but this is what it's saying here. Instead of this URL, it is the GitHub repo for Linux, and that is the fetch URL. So when you're trying to fetch something, it goes through GitHub, processes the pull request, and depending on the privacy and security of the repo and whoever created it, then you can either pull it directly or you'll have to go through some approval process, all sorts of things like that. So you can see here that a lot of people are trying to pull from the Linux kernel. So now let's talk about push. So push is directly from your machine. And now there's another URL here, which is the exact same, because again, we're trying to do a cycle for our repository. But what some people can do is, or what if you want, you can do, usually this isn't very found commonly, but sometimes it's people do it for many different reasons. But you can have one repository for pulling and one repository for pushing. This can be for a various amount of reasons, but usually that's not done. Because what we're trying to do here is create some sort of a cycle. So fetch is pulling the information from your repository, and push, I'm sure you can guess what that does. So again, running a similar command, we can push the information from our local repository and update the repository on GitHub or wherever hosting or shared server that you're running on. So you can see here that the push and pull cycle is really not that hard to understand. there's just a few commands that you need to know to be able to perform all of these tasks. And just what you have to take away from this video is that once you connect to a repository, you basically initialize this cycle of pulling and pushing information, continually updating it in a loop between your local machine and your remote repository. All right, let's move on. So in this video, we're actually going to be getting deep in the main part of this section. We're going to be pushing and pulling and actually bringing Git and GitHub together. So you can see that if you go to the main page of your repository, it's going to look a little bit different. And that's because I just made a mistake here and added a folder instead of a file for my license. So that's what we're going to do now is we're going to create the README, the license, and the gitignore. But for now, what you're going to want to do is if you look at the top of your page, there's going to be something saying, oh, so, we recommend every repository have a README license. Just click on the README button and it's going to take you to where you create a new file. So I'm just going to create a new file. Again, you probably won't be following along since it looks a little bit different than it does. So it should be mynewrepo/readme.md. So it should be in the root of your repository. Once you're done with that, you can put whatever you want here. And then you're going to, under commit new file, you're going to type the commit message that you want. So created readme proper. Now you don't have to type proper because I just made a mistake. So I'm going to make sure that I know that I made a mistake before. And then under here you have an extended description if you want. I'm not going to put that. Now you can say either commit directly to the master branch, which is what you're going to do, or create a new branch for this commit and start a pull request. So we're not going to do that because we don't need to pull anything right now. We're going to pull the master branch later on. I'll explain pulling and everything later, but we're just going to commit this new readme, just like that. So now it'll probably look a lot more familiar to you. The next thing I want to do is go and create a license. So I'm going to go and click on create new file. And I'm going to call it license in all caps .md. Then this button will appear saying choose a license template. You're going to click on that and now you can choose the license you want. Now I'm going to choose the MIT license. Pretty much this just allows people to take your project, distribute it freely. But if you're developing something else, you can choose any one of these licenses. I'm going to just go with MIT for now. So then you can maybe, mess around with some of the stuff here, year 2018 and your full name. Of course, I'm just going to leave that blank for now, but you can enter the proper fields that you want right here. And once you're done with that, you add the license and everything will be done. I'm actually just going to add my name. There we go. Review and submit. So there we go. Now the license template is finished. So you can always type this up from scratch or copy it from the internet, but I would recommend just going with the wizard that Git provides you. So now after that's done, I'm going to say added license under my commits. And I'm going to say commit directly to the master branch. We don't really want to create a new branch. So added license, commit new file. There we go. So you can see that already Git offers a really nice interface for you to create and mess with files. And obviously you wouldn't do everything through GitHub. That's not what it's made for, but it would help. So let's just keep that in mind for now. So there we go. We added our license and our README. And I'm actually going to later on when we pull everything, I'm going to delete this folder and I'll show you how we do that in just a second. But then the last thing I want to create on GitHub is our gitignore. So I'm going to go and create new file and I'm going to call this .gitignore. Just like that. And it says here, want to use a gitignore template. We don't want to use a template because this provides templates for different libraries, technologies, and of course we don't want to use that. You can go ahead and search for one if you want one, but we're not going to choose anything. So we're going to go ahead and make an autogen folder. Maybe ignore that just to prove that this is a working gitignore. So I'm going to type it just like that. And once I'm done, commit like that, and I'm just going to say created gitignore. And of course, as usual, commit it to the master branch. There we go. So now that we've done all of that, we have 4 commits, 1 branch, 1 contributor, and under an MIT license. So our repository is starting to look a little bit better now. It's not just empty. And the reason that I did all of this after we created our repository is so that we could connect to it through Git and the terminal. So now that that's done, why don't we start actually pulling our information? So I'm going to talk about pulling in just a second, but one thing you need to know is that sometimes, especially with more complex repositories, some conflictions and errors could happen, and they usually get very confusing after a while. There's a lot of different conflictions and conflicting information, so if it doesn't go smoothly, don't worry. You can either go and Google search it. I'd recommend that because there's a huge list of articles, and these problems usually happen a lot. But if you're still stuck after Googling it, go ahead and ask a question. But this is usually with more complex repositories with hundreds of commits, something a little bit bigger. So this is just a brand new repository with 4 commits. It's not really that big. So there we go. We have a repository now. Let's start pulling the information. So here's what we're going to do. It's called git pull, and then we have a few options from here. We can either type just git pull, and this is going to take all the information and update our local repository, or you could go git pull origin and then the name of the branch. So you could say, for example, git pull origin master, but because there's only one branch, we don't really need to do that. We can just say git pull, and it will pull all the information. Now, sometimes it might prompt you with a login, but usually it doesn't do that. So you can see there, that's what it's saying. It's saying counting objects and all of that, so it's taking everything from there. So now it says there's no tracking information for the current branch. Please specify which branch you want to merge with. So it says see git pull 1 for details, and basically what's going on here is the git pull is not really working because there's no branch being tracked. So we have to actually track a branch first. So this is where your git pull origin master would come in, since there's no branch being remembered. And of course you can see here, there's a way to set tracking information for a branch, so you don't have to go through that again. But we're just going to go through this command for now. Sorry for that if it didn't work for you. It's a little mistake I made, but there you go. So now it says here, from HTTPS and the name of the repository, star branch master to fetch head. So pretty much what this is saying is now the head is at all of the fetched information. So why don't we go ahead and check our git status. On branch master, nothing to commit, working tree clean. Git log. You can see that we have our 4 commits right here. Even though we didn't do anything in our repository, we have, or in our local repository, we have 4 commits here. So there we go. Now everything's working. You can see our head is on master and then origin/master. So our head is on the remote branch and the master branch. So now let's start editing our work a little bit. So this is pretty obvious. We can remove repositories, everything like that. I'm going to go ahead and list everything we have here. And you can see we have all of these different files and folders that we didn't have before. If I go ahead and open up in my file explorer as well, where is it? Git remote con. You can see everything's there. So what I want to do is remove the license folder, and then I'm going to push all the information back and remember the branch this time. So what I'm going to do first is rm-rf, and by the way, a command you can also use is rmdir. I'm just going to do rm-rf. I just feel that it's more memorable for me, but we're going to keep it like that. And then I'm going to type the name of the folder, license. There we go. I removed it. Let's list it. So we're going to check the status, just our regular commits, git commit -m removed mistake folder, just like that. There we go. So now we committed it. So if we check our git log, you can see that the origin master branch ends here, and then the head is on the master branch. So these are 2 separate branches right now. So what we want to do is package all of this up and update the remote repository so that the origin master branch and the mistake branch or removed mistake folder master branch match up. So this is actually quite easy. It's very similar to our pull command. What you're going to type out is git push this time, and you're going to add a -u flag. So what this does, and I'm just going to actually stop right there. What this does is pretty much remember the branch that we're pushing. So this is what we're going to do. Is right here, git push -u origin, and then master. So we're going to push the master branch back up to our new repository, right there, like that. So we're going to click enter. Just wait for that to load. So now it's going to ask you for your username and password. So I'm going to type out that. So So this is some really nice security added in. So I'm going to type my password as well. And by the way, it doesn't actually show you your password. That's one thing with the terminal when you're entering your password. So there you go. That's just one thing you need to keep in mind. So there you go. You can see that it said remote resolving deltas, everything. So it said branch master set up to track remote branch master from origin. So what this is saying is that now the master branch is being remembered, so you don't have to type the name of the branch every time. So let's go ahead and check our GitHub repository and see what happened. Now you can see it's been updated with our commit that we made in our terminal. So you can see that this cycle is starting to work a lot better now. We have only one branch, remember. We have 5 commits, 1 contributor. So there we go. You can see that it's all working, and whoops, it seems like I removed the license file instead of the folder. So why don't I go ahead and actually create it again, and then we're going to pull the information just for a little bit more practice. So let's go ahead and do that. We're going to create a new file. We're going to call it license. And remember, we're just doing it again since I accidentally deleted the license file instead of the folder. So just make sure that you don't make a mistake with that. And I'm going to enter my full name here, just like that. So then let's go ahead and create our license. There we go. So I'm just going to added new license. I'm going to put it on the same branch, commit the new file. There we go. So 6 commits. Now what I want to do is go and pull it from here. So this is much faster now since I can just do git pull, and it will, because since it's tracking the branch now, you can see here it didn't give me any errors or anything like that. It worked perfectly. So I'm going to list everything. So now I'm going to remove license.md. You can see that there's some highlighting there that I might have missed because it's a folder. So I'm going to rm-rf license.md. Just like that. So there we go. Now git add dot git commit -m, and we're going to commit our other commit. So there we go. Removed proper mistake. And usually you wouldn't do this. Usually you just revert back and do the whole thing again. But since we're trying to get some practice with push and pull here, I'm just showing you how to get used to it. There you go. So now we're just going to push it to the branch, but this time we can actually use git push instead of git push, origin master, all of that, because we remembered the branch. So I can just go git push. And what that's going to do is it's still going to prompt me for my username and password, but what's going to happen is it's going to use the remembered branch that we entered with the -u flag, and it's going to enter that. Now I already committed it. If I actually go up, I'll show you right here. I used git push origin master instead of git push. So I just wanted to prove that point. I'm kind of used to saying origin master just because I like to push different branches. But don't worry about that for now. So the remembered branch is our master branch, and it's being pushed and pulled without having to specify it. So let's go ahead and refresh and make sure everything's working fine. 7 commits, that license folder is gone, and now we have everything set up. So there we go, we have 7 commits, and we've been interacting with our repository from both Git and GitHub. So this is where it gets really powerful. Here you can go off, you can do many different things, and it just gets really nice. So in the next few videos, I'm going to be talking about pushing different branches and some of the mistakes between them, maybe some complexity issues. So we're going to be talking about pushing different branches, because right now we only talked about pushing the master branch. So in the next few videos, or in the next video actually, I'm just going to talk about pushing and pulling different branches. All right, let's move on. So in this video, or the last video in this section, I'm going to be talking about working with remote branches. So right now we've only been working with one branch, which is the master branch. And usually this is how it would go for most of your projects. But if you're working on something for a client, let's say a website, usually if they ask you to make revisions or changes, or let's just say something's wrong, there's a typical process that you would follow to fix this error. Now usually what happens is you would create a new branch, fix the error, then merge it with the master branch, And when you're done, delete that branch. Now, since we're working with GitHub, it's a little bit more complex, but I'm going to be going through with this today. So I created this new JavaScript file. You don't need to know JavaScript to know this. Don't worry about it. If you don't know any programming, just forget it. You don't need to know any programming. I'm just going to show you the kind of process flow that's going on. So I'm just going to open up this file, preview it in GitHub. You can see it's a function that doubles an input number. So just if you don't know programming, just think of this as just some random code. Now let's just say this is made for a client and the client says something's wrong with this function. It's not working. And I'm sure everyone can see the error right here. So what we're going to do is pull this into our local repository. We're going to create a new branch, fix it, push it back into our GitHub repository, and then we're going to delete that branch. So the branch is going to be used to fix the error in a way. So usually this is how it would work for most of your projects. You would create branches for fixing errors or making revisions, and then when you're done you would merge it and finish off with that. Okay, let's get started. So the first thing I want to do is pull everything into my local repository. So I'm just going to use git pull to get everything and pull it into my local repository. There we go. So a few changes were made. You can see that func.js was added. I'm going to go ahead and open that with my text editor. You don't need a text editor like this, like I have. You can use Notepad, Notepad++. This is just it's an IDE, so it helps with highlighting whenever you're doing programming projects. So don't worry about that. But you can see here that we can clearly see the error. It's supposed to double and it's tripling it because it's timesing it by 3. So what we're going to do is create a new branch, and then we're going to work on fixing this error. So let's go ahead and do that. So I'm going to go and create a new branch, Git Checkout -B, and then the name of the branch. In this case, it would be ERR1. I'm just going to call it that for our first error, or O1, depending on what you want to call it. So I'm going to do that, and now we're on the new branch. So let's go ahead and fix this up. So what I want to do here is just fix up the error. So I'm going to change this to 2, save the file, and now if we check the status, we can see that it has been modified. So now I'm going to add everything to the staging area, commit it, say fixed error. There we go. There we go. So now next thing I want to do right now, that's just the final thing, is to merge the branches. So I'm going to go ahead and merge that now. So I'm going to switch to my master branch, Git Checkout Master, and hopefully you remember how to merge branches from the previous section. So now I'm going to go git merge and then the name of the branch, ERR01, error 1. So there we go. You can see that it has been merged now. So let's go ahead and check our log and see what's going on. So you can see right here that we have a bunch of new things here. When we pulled it, it added this doubling function, which is where our origin/master branch is. And then up here, you have fixed error. So we have master and ERR01. So this is kind of how it would work. A new branch has been created off of the doubling function. And off of that, just somewhere in the other branch, we fixed the error and then merged it back together. So now what we want to do is delete the error1 branch, but we're going to do it after pushing it to our GitHub repository, just to show you how you can delete remote branches. Now you can totally do this from here. You can go remove the branch from your terminal and then push it, but I just want to show you how you can delete remote branches, just so you know and get a feel for working with remote repositories and all sorts of things like that from your terminal. So what I'm going to do, I'm a little bit stuck here in my Git log, so I'm just going to close off the terminal really quickly. Go back to my my path. So I'm going to go find one of my softwares. Where is it? My path. There it is. Copy that. CD into there. Sorry, this is taking a while. So I'm going to CD into git remote. And there we go. So now what I want to do is I have the branches, I have everything set up. So I'm going to go ahead and push it to our repository. There we go. So the Git and GitHub course, and just a little something, you do have to do this every time you want to push something just for security, because if something didn't work, or if someone was trying to breach you, they could easily push some malicious code onto your GitHub repository. So that's why it asks for authentication. So there we go, we pushed it. Let's go ahead and check our thing right here. So you can see here we have 9 commits and we have 1 branch. Well, let's go ahead and check what's going out. You can see we have the default branch master updated 3 minutes ago by Videolab. What's going on? So pretty much what's going on here is that we didn't actually push the error01 branch onto our GitHub repository, because what's going on is we just typed git push, and hopefully you noticed that, because what I'm trying to prove here is that when you can't just type git push and expect everything to go. What you need to do is push each individual branch, and that's what this whole video is focusing on, is trying to make it aware that each branch is kind of separate and you need to deal with them separately. So what you would do is git push origin and then err01, and then you would enter your username and your password, just like you normally would with the master branch, except this time we're pushing our error branch. So there we go. So now you said to this here, right here, star new branch error01 to error01. There we go. So let's go ahead and refresh our Git and GitHub course. And now you can see we have 2 branches. There we go. So we have our err01 and we have our master branch. So there we go. Now we have both of our branches and it's all fixed up. And why don't we go ahead and check out our commits. Right there, you can see that's where we fixed the error. So there we go. Gonna go to the branches. So you can see there's all sorts of different things here. But pretty much what's going on is we merged the branch, we created the error branch, we fixed it, we merged it, and now it's all finished. So that's why when we actually go to check fixed error, you might have noticed that it says master. It's because we merged it together. So now that that's done, we don't really need the error branch anymore since it's been fixed. So why don't we go ahead and remove the branch? This is actually very easy to do, and you don't need to pull it and push it and do all of that. All you need to do is type out one simple command. So we're going to go over to your terminal, and once you're there, you're going to type git push origin -- delete, and then you would type the name of the branch. So in this case, it would be err01. So you can see that this is quite useful because you don't need to pull and then push. It just pushes a delete protocol. There we go. So then, of course, you need to enter your username because it's still a push. There we go. So it's just going like that. There we go. So it deleted the error01 branch. So let's go ahead and refresh now, and hopefully it should say 1 branch. Oh, whoops. Yeah, you see there, it's a 404 error because this branch doesn't exist. So if we go back actually, right here and refresh the main page, it's going to show 1 branch now. So there we go. That's deleting and working with remote branches. So I hope you understood that. It's a little bit complicated, but once you get used to it, it becomes quite easy, especially if you're working for clients. Making branches is kind of the norm because if something goes wrong and you mess up everything, you can just switch back to the master branch and wipe out that branch. So it doesn't interact or interfere with anything. So there we go. We're pretty much done with our stuff here. We're pretty much done with branches on GitHub and in remote repositories. Again, I would recommend that you go and after we've learned all of these commands, it's kind of hard to keep them straight in your head. It was actually hard for me to remember this, but what you can do is go check out the Git cheat sheet. It was in the Git basics section on the article. All you have to do, just go open that up. It has all of the useful commands, the ones that you most use, because let's be honest, it's really hard to remember and keep all these commands straight in your head unless you use them 24/7. So I'd recommend you go check it out, try and see if you're forgetting something, and yeah, that's pretty much it, because you don't really need to memorize these commands. It's not a necessity because Google's always 1 click away. So yeah, that's it for Git and remote Git. So now we're going to move on to using SourceTree and a GUI. So this is optional, you don't have to take it. But if you don't like using the terminal and if you prefer to use something a little easier, so, you know, a little bit more user-friendly, go ahead, look at that section. But if you don't like SourceTree or GUIs and you just want to stick to your terminal, go ahead and move on to the goodbye section. You pretty much finished the course. Congratulations. But if you want to stick around, go ahead. I'd highly recommend you do. It gives you an alternative way of looking at things in Git and GitHub. All right, let's move on. So now that we're done with the Git GitHub part and we're pretty much experts on it, it's time to move on to an alternate way to use Git and GitHub. So let's get started. Pretty much in this section, we're going to look at all of the skills we've learned, except we're going to do it through a Git GUI. So we're going to explain what GUIs are. We're going to look at them and, you know, how are they better than using something like a command line or a terminal. So we're going to look at all of that, and then we're going to look at using one of these GUIs for Git. It's called SourceTree. So we're going to really speed through it. We don't need to explain all of the features, commits, things like that. We're just going to go straight through it and see what's going on so that we can get used to the whole GUI environment, because we've been doing everything through a terminal so far. So getting used to something like a GUI with Git is a little bit difficult at first. So first of all, we're going to look at some of the basic features on SourceTree. So init, add, commit, all of the things that we learned in the Git basics section. So we're going to look at these, but we're also going to try and point out some of the differences between using a terminal and a GUI like this, like SourceTree. After that, we're going to look at the network features. So after we learn all the basics, branches, everything like that, we're going to move on to look at remote features. So pushing, pulling, deleting branches, and pretty much what we did in the last section, or in the last two sections actually. And we're going to try and use this in SourceTree. So it's much simpler in SourceTree than many people think. Mostly in the terminal, it's quite complex, connecting and all of that. But once you use SourceTree, it becomes a lot easier. So there we go. We're going to talk about that. But that's pretty much it. SourceTree is not the most complex software to use. It was made with user designed UX in mind. So we're going to be, speeding through I'm going to explain some of the differences so you can kind of adjust to using an environment like this instead of a black and white terminal. So we're going to go and work with that, try and get some experience, and then finally we are going to finish off with this course. And by then, hopefully you should be an expert in Git, GitHub, and in two different ways of using both of them. All right, let's move on. So in this video, I'm going to be giving a quick introduction to SourceTree, graphical user interfaces, GUIs, and I'm going to be going over all of that in this video so that when we start installing it, you have kind of an idea of what it does. So before we get into SourceTree, let's explain what a GUI is. So a GUI, or graphical user interface, is pretty much just anything that allows you to perform tasks or interact with your system through something graphical, so a graphical interface, so icons, notifications, buttons, things like that. So you can probably already come up with some ideas of GUIs. They're used all over, but pretty much they're built off of something, or a system or a library, and these systems and these libraries are usually interacted with through command line or through programming or some form of advanced interaction that usually the average user can't do. So what GUIs do is make it more user friendly by making everything visual so that more people can have access to those systems. So here are some examples of GUIs. Pretty much any version of Microsoft Windows and any operating system in terms of how they work, for example, their desktop, icons, apps, things like that, they all work in this GUI kind of manner because all of this can be done through the command line. You do not need icons and desktops and things like that. You can do it all through a terminal. But what happens is, because most people don't know how to use a terminal, so what Microsoft does and what Apple does and any other producer of operating systems is they make these series of icons and apps and designed it so that it's more accessible to the average user. So that's pretty much what a GUI is. Google Chrome, any browsers, games, all sorts of things like that. Games not so much because they're meant to be GUIs. They don't really interact with anything, but that's pretty much what a GUI is. It's just something that allows you to interact with it in a more user-friendly way. So let's talk about SourceTree now. So SourceTree is a GUI that allows you to interact with Git through a graphical interface. It uses icons, trees, and a lot of visualization. So it makes it easier for not just the average user, but for anyone who prefers visual kind of development. Because a lot of people, they prefer to use, what you see is what you get tools, especially for website development. These days, especially things like WordPress. They use it kind of to just make the whole experience a little lighter, because developing things from scratch these days is a little bit hard. Well, it's always been hard, difficult in a sense. So a lot of people are using visual programs, things like that, to make their lives a little bit easier. Now, you don't necessarily have to use it. In my opinion, I prefer using a terminal when using Git, but some people like to prefer, using something visual, something like a program, something tangible, which they can, interact with. So that's why I'm making this section, is for those people who don't like the terminal that much. So, maybe if you use SourceTree, something a little bit more your style, you can get up to speed with Git and, really understand how it works. So in the end, SourceTree is just a Git GUI. It allows you to interact with your repositories and do all the commands just through a graphical interface. So it completely builds off of Git and the commands you can use on the terminal. So it runs the same things in the terminal, except the thing is it does it through your program. So you press a button and it does it for you, instead of, having to type it out in the terminal yourself. So that's just a little idea of what SourceTree is. All right, so now that you know what SourceTree is, we're going to move on, start installing it, setting it up, building accounts so that we can move forward and start using it in our repositories. All right, let's move on. So in this video, I am going to be installing SourceTree, setting up an account so that we can start using it in the next few videos. So the first thing you want to do is go over to sourcetreeapp.com, or you can just go into your search engine and search SourceTree. Then, once you're that, you are going to download it. Now, I have Windows, but you can go ahead and download it for whichever version you want. You cannot use this on Linux, however, I'll just make that clear. So you can either use it on OS X or Windows. So I'm going to download it for Windows. And we're not going to use Bitbucket for now, since we're only using SourceTree. So you're just going to download that, and it's going to set it up for you. So you're just going to open that up. Wait for it to load. And once it's there, we're going to set up our account, because you do need an account to use this. And we're just going to work with it so that everything is ready for us to start creating some brand new repositories. So let's just wait for that to load now. All right, there we go. It's extracting. There we go. So we're here. So it says here, SourceTree is a Git client provided completely free by Atlassian, who, by the way, made Gitbucket. So you're just going to agree to everything, send data, whatever you want. Click next. So you're going to either register your account, you can either use your Bitbucket server or your Atlassian account. Now, you're just going to go ahead and open up and just create an account. It's free and everything. You don't really need to. You can even use Google if you want, which is what I'm going to do. But you can use your email, do whatever you want. I'm going to log in with Google. So there you go. Now that I've registered my account, now you can either download Mercurial, which we're not going to do, or here you would download Git if you don't have it, but assuming that you took this course, you probably already have Git. So we're just going to untick Mercurial since we don't need it, or skip it, doesn't really matter. And there we go. So now it says here, load SSH key. Do you have an SSH key that you'd like to load now? We don't really have one, so we're just going to click no. And there we go. SourceTree is now installed. Very simple. It doesn't take that long. I'm just going to make it full screen there. We can do all sorts of things with this, but in the next video, I'm actually going to be creating a repository that we can now start using. All right, let's move on. So in this video, I am going to be creating a brand new repository in SourceTree. Now it's a little bit different than just typing Git in it and having a repository. You actually need to do a few extra steps before you go ahead and start making commits. So let's go ahead and get that set up. First thing you want to do is head over to SourceTree. Just wait for that to open. There you go. Next thing you want to do is go to local repositories. Now usually they'll be on here by default, but if you've been using it or for some reason it's on remote, make sure it's on local repositories, because we're going to create this locally for now. Next thing you want to do is go and click on create. So you're going to set the destination path. So this is where the repository is going to be. Usually you'll just go to wherever you store your projects and create a new directory, all of that. So I'm just going to call it my Git GUI project. There we go. So I'm going to select that. There. So now you want to make sure it's on Git, not Mercurial, because we are using Git, not any other source control. So there we go. Let's create it. So it says here a warning saying, you know, the path already exists. Don't worry about it. Just click on yes. It's not going to overwrite any of your data. And there you go. That's pretty much it to creating a brand new Git repository. It's really simple. It doesn't take much time at all, actually. But in the next few videos, we're going to really dive into SourceTree. We're going to get familiar with all of the different things we have here. You can see we have a lot of brand new tabs, and I'm going to be taking you through everything here, creating some files, looking at the staging area, things like that. All right, let's move on. So in this video, I'm going to be giving a quick introduction to the SourceTree environment. So I'm going to be going through working with all of this, and then in the end, we're going to start working on making some commits. So this is what our SourceTree environment looks like for now. Now you can't really see anything since there's nothing to commit, but I'm going to go ahead and open up my Git GUI, and I'm just going to make a new file, and I'm just going to call it something random, maybe, you know, text, something like that. There we go. So let's go ahead and check our SourceTree. So there we go. You can see that we have a brand new window here. So I'm not going to go through and actually do anything, but I'm going to give a quick introduction to the environment here. So first of all, on the top bar, we have a few options. Under commit, when you click on it, it's going to bring up a window that allows you to type in a message and, you know, commit your files. Under pull, you can actually pull information from a certain repository. Now, once we do that, it's going to pull it into our local repository, and we'll be working with that towards the end of this section. You can also push and fetch, so pretty much the same things. Then you have things here. So if you click on this, you can actually create a new branch. You can delete branches. Here, you can merge the branches. So here it brings up a little window. You can, you know, it shows all the branches. You can click them, merge them together. You can do all sorts of things. So that's pretty much all of the different commands that you can do. Now, adding and committing, adding, removing, you know, working with the staging area, you can't just, there's no buttons up here that says add, remove, commit. Well, there is a commit button, but this is all down here. So you can see here that it says staged files and unstaged files. So in the unstaged files, it's going to be the changes or the untracked files. And you can actually right click each one of them and add them separately if you want. And then up here is going to be the staging area. Now, if you click on the file, it's going to bring up a little window here showing all of the changes that you've made. So what lines you've added, what lines you've removed, and what lines you've modified. So I think that's a really cool feature. You know, you can see what's going on. Also under here is pretty much your commit bar where you can see what's going on. So under commit options, there's a few things you can do. We're not really going to work with them. You know, there's some of them pull requests and some just more advanced options, but we're not going to really go over those in this course. So we have this thing called Git flow up here, which is pretty much like a template for your repository. I'm going to go ahead and click on it. You can see here we have a production branch and a development branch. So we actually worked on this a little bit earlier. I showed you we worked with it with the terminal. You can see here we have a development branch and a master branch. So that's kind of what Git flow does. It sets all of that up for you by default. So kind of like a template. You click on terminal and it's going to open up Git bash in the directory or in your repository. You can see by default. So I think that's a really useful feature. If you want to play around or do something with the terminal that it's a little bit hard to do with the GUI. You can also open up an explorer, and in settings, you can work with the remote repository path that you want, all sorts of things like that. So we'll go over that later, but you know, configuring the settings and everything. So I'm just going to go ahead and commit the file really quick here. Don't worry about what I'm doing right now. I'll teach you all of that in the coming videos. So of course you're going to enter your details. I'm just going to put my email and my name, just like that. There we go. So I'm going to commit it. Seems like that's having a little bit of trouble. Anyway, so what you're gonna do, you commit it, and then if you go here to working copy, what it's gonna do is pull up all of the history of your commit. So it seems like it doesn't seem to be working here. But there you go. So what it's gonna do is pull up pretty much all the history of your commit. Now, of course, I can't show you that now since it doesn't seem to be working, but it's going to show all of these different nodes and the text from the commit. So it's a really nice way to look at your commits and see all of it in a more visual sense, because through the terminal and your Git log, it doesn't really show you what's going on behind the scenes. It's really hard to visualize it. So I feel like that's one of the best features of using a GUI like this. You can actually see what's going on. So you also have a few more things right here. So you have remotes, which is going to show you all of your remote repository, stashes, which is a way of sort of storing uncommitted changes if you're trying to push or pull or do something like that. If you have changes that aren't committed, usually this would happen when you have a bigger project, not something like this. You have a few other things as well. You have tags, you have branches, which is going to open up a list of branches. And of course you have your file status, like I was just saying. If you open up working copy, what that's going to do is pretty much just show you your history. So all of the commits that you've made. If we also open up log/history, you can see right there, that's what I was talking about. It is kind of like the nodes that you've made. We have one node, which is all the uncommitted changes. It doesn't seem to be working the commit, as you could see, but here's where you would see all the commits that you're making. So if you make another commit, it's going to show there. If you make a branch, it's going to make a literal branch. It's going to show you how everything is looking. So like I said, this is one of the best features of using a GUI. You can really visualize what's going on. All right, there we go. So that's pretty much it for the introduction to SourceTree. It's a pretty nice software, and that's why we're covering it. But as we go on, we'll actually get used to more of the features. This is kind of more like a preliminary, so you can get used to some of basically the environment, because it's quite a sharp adjustment from a terminal to a program. So it's better if you just get used to all of the different features. It's a little bit tough to work with. So what we're going to be doing over the next few videos is not only introducing some of the SourceTree features, but actually going through and trying to integrate the Git features properly into SourceTree. All right, let's move on. So in this video, we are going to be starting to stage and commit files in our SourceTree repository. So I actually finally made the commit. It just took a little refresh for it to work. And you can see now, if I go over to my working copy, my branches, everything, you can see that everything's working. So you can see how that node structure works. But in this video, we're going to be making a few changes, adding a couple files, and we're just going to get used to the SourceTree environment with staging and committing. All right, let's get started. So the first thing I want to do is talk about adding new files and committing them. So what I'm going to do is just go and make some new files. So oops, didn't mean to open Git Bash. So I'm going to go here, my Git GUI project, and first thing I want to do is create a new folder. I'm just going to call this src source, and then in here I'm going to create a few text files. So I'm going to say script, hello, something like that. Doesn't really matter what we put here. Just go like that. Then what I'm going to do is go back, and you can see that something's happened here. So we have two new files right here. So it says here it's on the unstaged files box, and what this is pretty much saying is that they haven't been tracked yet. They haven't been added to the staging area. So what we're going to do now is go and work with them so that we can add them to the staging area. Now you can either go and right click on each one, and from here you can go and add them. You can remove them from the staging area. Remember, this means unstaging them pretty much. You can ignore them, which pretty much adds them to a git ignore. Resolve conflicts, you can see, but this is for conflicts. So when there's some error going on, usually it's between the working copy and the index. When you're checking things out, some conflicts happen, but we're not going to go through those now since we're not really doing that. So what we're going to do is go and stage them. Now you can either stage each one like I said, or you can just click this stage all button. From there, it adds them. Now you can see it has a plus icon, and this doesn't mean plus added to the staging area. This means that two new files have been added, the hello and the script. Now from there, of course you can't view anything in this because it's we didn't put any text in it, but from here you can actually go ahead and commit it. So at the bottom here, you can see that there's a little window here. You have your username, your email, the ones that you put in, and from here you can type in whatever you want. So I'm going to say added new files under source. I'm just going to say that. Now I'm going to commit it. So once that's done, and we go back to our working copy, you just click on that. Hello. Yeah, there we go. So you can see here that it says nothing to commit. And that's because, you know, we've committed everything. There's no new changes. Now, if we go over to branches, you can see that there is a new commit. It says add new files under source. And you can see here it says the name of the branch where it's located. So that's also really handy. So let's go back to our working copy right here. So usually when you see this screen, it means you have a clean working directory. You don't have any files you need to commit, and you don't have anything you need to change, which is a really good sign. So let's go ahead and start working with editing some files, deleting them, working with them a little bit more. So I'm going to open up this hello file there. I'm going to type hello. Let's go ahead and save it. And why don't we just go ahead and delete this script file. Let's go back here and see some of the changes. So you can see here it has a minus, which means that it's been deleted, and this is a ... which means it's been modified. And if we actually go and look at this, it says plus hello, which means we added the line hello. So we're going to stage all, and remember this is deleting the file, not removing it from the tracking area. And once that's done, we're just going to make a new commit. So remember, if you don't see this screen, you can just go and click on commit, and that's going to bring it up. Now we're just going to type remove script and modified hello file. There we go. So let's go ahead and commit that. There we go. So that's committed. Let's go ahead and check it out on our master branch. So you can see there that we added a new script and modified the file. So this is pretty much the essence of adding and working with files. But what if we want to, let's just say, untrack a file? What we can do is, let's just say, you know, we want to create our autogen file as we always do. Oh, whoops, autogen folder, I meant autogen. There we go. And in there, I'm going to add my log, as we did in the Git basics section. So I'm just going to add some random text to this file, go back here, and now you can see we have unstaged files, autogen/log.txt. Now, one way you could do this is by going and creating a gitignore, but for this time, we can actually right-click and just click on ignore. Now, what this is going to do is ignore this. It's going to put it in a gitignore. So what's going to happen is you can either ignore the exact file names, ignore all files with this extension, which we're clearly not going to do because we have a lot of txt files. But what we're going to do is select this. So it ignores everything after or in this autogen folder. There we go. So ignore for this repository only. And now you can see it created our gitignore and it added it to it. So what we're going to do is stage all, and you can see that that autogen change has disappeared, and we're going to say added gitignore. There we go. So that's pretty much the essence of you know, committing, adding, removing. We pretty much covered the entire Git basics section in one video. And remember, we're going through this quite fast because we've already learned all of these skills and techniques behind doing it. We're just doing it in a different software. So that's why I'm going through this quite quickly. So there we go. Now we have 4 commits all ready and set up. And in the future, we're going to be creating some more complex things, such as new branches, merging them, things like that. And then after that, we're going to be working on using it remotely. All right, let's move on. So in this video, we're going to start working on interaction in SourceTree. So namely checkout, you know, revert, reset, things like that. So we're going to be working on all of the moving up and down the timeline. And we've already done this, of course, in Git. But now that we've worked through committing and staging area and the whole ignore and discarding, now we're going to actually start working on moving up and down the timeline. After this, we're going to work on the rest of the features, branches, remote repositories, all sorts of things like that. All right, so first of all, I'm going to go over and check my branches right here. So you can see I added one new commit. I added the lorem ipsum dummy text right here. So what I'm going to do is teach you how to check out. So I want to go back in time to a point where in this text file, I didn't have this text right here. So let's go ahead and do that. So first thing you want to do is select the commit that you want to revert to. So I'm going to say, let's just say added the gitignore, right click on it and click on checkout. And of course, it's going to give you the exact same warning that you get in the terminal. Checking out this commit will create a detached head and you will no longer be on any branch. So what we're going to do is go and click OK. So there we go. Now our head is on the gitignore. So if we go ahead and open up this text file, there's nothing there. So checking out is pretty easy, but what if we want to revert or reset? Well, the first thing I want to do is go and check out the latest commit, of course, as usual. So now we're back up to the master branch, the tip of the master branch. Usually you would call the latest commit the tip. And there you go. So now we're here. So what if you want to revert or reset? So you can see here that we can do a few things. Now let's just say I wanted to revert this commit. Let's just see. It says here reverse commit. So this is pretty much the same as saying revert. So let's just say I'm gonna click on it, reverse commit. So it says here, are you sure you want to create a new commit reversing all the changes in the selected commit? So this is pretty much what revert does. It's pretty much the exact same thing. They're just worded differently. So be careful for that. So I'm gonna click yes. And now you can see it says revert modified text file. So you can see that all of the changes have now been reverted. And under here, we can actually see what has been changed. So it looks, it's a really nice feature that I like. So there we go. Now, what if I say, okay, this is getting a little bit cluttered. I just want to go all the way back in time to added gitignore. I can right click and I say reset current branch to this commit. What that's going to do is pretty much reset. So now we can actually select the mode. So this is pretty much the exact same as the flag that we use, soft, mixed, and hard. So I'm going to say hard, discard all working copy changes. And the reason I'm doing this is because if we go to our working copy, of course, there's nothing here. So we're not really losing anything by going back. So I'm just going to go and do that. And it's going to give you a warning, just make sure that you know what you're doing when you're selecting this flag. So you're just going to click yes. Wait for that to load, and there you go. We reversed those two commits. So yeah, that's pretty much it for working with checkout and revert and reverse. It's quite simple. There's really not much to it because it's all done through a GUI. You know, you can just go right click on a few things, and it's done. So yeah, checking out, you know, interacting with the timeline. Once you get used to it and once you start adding branches, it becomes much easier to work with it. Than using something like a terminal. But again, some people prefer terminal and some people prefer SourceTree or GUIs in general. So yeah, now that we're done with, you know, moving up and down the timeline, you know, one basic branch, we're going to move on to creating and working with branches. All right, let's move on. So in this video, we are going to be working with branches. So we're just going to be doing it in the local repository, but we're going to be working with branches, creating them, removing them, and in the next video, we're going to be merging them together. All right, so you can see here that I created this fake new website. Just pretend that I created a website and there's some error in it. So just like before, what I'm going to do is create a new branch, try and fix the error, and then merge the branches together, then finally delete the branch. So what I'm going to do first is go ahead and create a new branch. But how are we going to do this? Well, it's actually quite simple. Right here up at the top, it says branch. So what you're going to do is just click on it, and it says here new branch, and I'm just going to say ERR01, just like we did in the terminal. Now it says commit working copy parent and then specified commit. So what we're going to tick is working copy parent, which is pretty much just the latest commit. So after that, we're just going to say checkout new branch. So it's pretty much the same as doing git checkout -b with the B flag. So all of that. And once you've ticked all of it, just like this, we're going to go ahead and click create branch. Now, if you want to create it off a specified commit, you can go ahead and do that. But in my opinion, I feel that it's better to just go off of the working copy parent, which is the latest commit. So I'm going to go ahead and create the branch. And there we go. We created a brand new branch. So right now we are on ERR01. So you can see here, we're currently on this branch. We can always switch back to the master by right-clicking and checking it out. But what I'm going to do is go ahead and remove the error. So I'm going to go open up my fake website. This error here, I'm just going to remove it. Now, of course, in a real production website, you would go find the error, remove it. You do a bunch of steps, but this is just for practice because some people, they don't really know all the languages, and I want to try and get it so that everyone knows what's going on. So I'm just going to remove that fake error. There we go. Let's go ahead and check out our working copy. Unstaged files, fake website.txt. We're going to stage it, and now we're going to commit it. So we're going to say fixed website error. Just like that. We're going to go ahead and commit that on the error01 branch. So now we're going to go ahead and view it, and you can see right there that it says ERR01 fixed website error. So there we go. You can see that it's now working. So that's pretty much it for creating branches and working with them. But now what I want to do is go and try and create a new branch and then delete it. So I'm going to go back to the master branch here. I'm going to create a brand new branch. I'm just going to call it dev or practice or test or whatever we want. It's just, we're going to delete it later on anyways. It's, same thing. We're going to use all the same settings. There we go. We have a new branch and we are currently checked out on it. So right now they're in the same position, which is why it has this dot here with test and error01. So what we're gonna do right now is we're gonna go and make sure that we're checked out on our test branch right there. There you go. And we're gonna go and try and delete it. So right now they're on the same branch and everything's working. So first thing I want to do is go and check out the master branch because we want to, we can't delete a branch while we're on it. So we're gonna go and check out the master branch. Now, of course, you can check out the error branch, but I prefer to be checked out on the master whenever I'm, messing around with other branches. Next thing I want to do is go ahead and click on this branch icon. Now this is where it gets a little confusing, and you're going to go to delete branches. Now I'm just going to take my test branch, and it says forced to delete regardless of merge status. We're going to go ahead and tick that as well, because if you remember, there was a lot of issues about, this branch hasn't been fully merged because it hasn't, and we were doing that in the terminal, and we used a uppercase D to force delete it. So we're going to go ahead and keep that ticked. Now we're going to go ahead and delete the branch. And there we go. The branch is gone just like that. So you can see how easy it is to work with branches in SourceTree. It becomes a lot easier because you can visualize it in this node tree structure right here. So next video, we're going to start merging the branches so that we can actually, bring it all together in terms of branches, so that we can start seeing what's going on. And by that point, I think everything will be a little clearer, especially with most of the Git icons, most of the commands that you can use in SourceTree. All right, let's move on. So in this video, I am going to be finally merging branches. So we're getting closer to the end of the SourceTree section since we ran through everything pretty quickly. Actually, all of the videos were under 5-6 minutes, so we can clearly see how much we've progressed in Git, and hopefully you've progressed in Git as much as I feel that everyone has. Alright, so enough of that. Let's start with merging branches in SourceTree. So merging branches in SourceTree is really not that difficult. It brings up a little wizard. You can select the branches that you want to merge, and it's just overall a very, very easy process. So the first thing you want to do is make sure you're you're checking out the master branch or whatever branch you want to merge your target branch into. So for example, if I want to merge my error branch into the master branch, what I would do is make sure I'm checked out on the master, just like we were doing in the terminal. Next thing you want to do is right up here, you're just going to click on merge, and it's going to bring up this wizard here. So it's going to say up here, pick a commit to merge into your current branch. So what we're going to do is select this, the fixed website error branch. Next thing I want to do, go ahead and click OK. And there we go. You can see now master and error are on the same page. They're on the same branch. So that's all working perfectly. So you can see there that all of the commits up to there are working fine, and then we have our error1 and our master branch right there. So it says fixed website error. So you can see new fake website created, and then here it says fixed website error, and the error has been removed. So you can see that branches are really easy to work with in SourceTree. Like I said in the last video, even merging becomes such such a simple topic. And let's not try and, say everything's easy because we haven't gotten to the remote part yet. But for now, I think we can say it's safe to say that most of this stuff is quite easy. I mean, we've already finished merging the branches, and so everything just becomes a lot easier when using this. Alright, so enough about talking about how good SourceTree is and how GUIs are great for Git. Let's actually move on to finally deleting this branch, since we don't really need it anymore. So what you're going to do is right click on the branch, and right here there's a few options, but what you're going to do is click on delete ERR01. Now it says here, are you sure you want to delete the following branches? You can also do a force delete. I'm just going to click OK. And there you go. Now we only have the master branch left. Now, like I said, if you want to keep your branches, for example, to development branch, go ahead. But because that was an error fixing branch, you don't really need to keep it, because that's mostly created just for security in case something goes wrong. So yeah, there we go. We merged the branches and we deleted them. And obviously, as your development projects get a little bit more complex, you're going to need to create multiple branches with multiple commits. But following this same rule that has been taught in this course, I'm sure that you can take care of any problems you might have. Alright, there we go. So we're done with merging branches. In the next video, we're going to move on to push and pull requests and finally bringing everything together with GitHub. Alright, let's move on. So in this video, we're finally going to be moving on to remote repository management through SourceTree. So we finished up with branches and managing the branches. Now we're going to move on to actually moving our repository using the push and pull cycle and doing all of that. So first thing I want to do is go ahead and clarify what are we going to do with creating remote origins. So we've done in the past git remote add origin, and then we've done the URL. But in this video, in this section with SourceTree, it's really hard to create a remote origin using the GUI. So we're just going to go ahead into the terminal and create it. But then everything after that is done through SourceTree. Alright, so first thing we're going to do is go ahead and create a brand new GitHub repository. Make sure it's blank, no readmes, no licenses. So just make sure fresh repository, don't add anything, just like usual and how we did in the past. Next thing you want to do, go ahead and copy the URL. So just as usual, you're going to go and copy this, and we're going to add a remote origin. So if you go back into SourceTree, there's this really handy button in the top right, which allows you to open up a terminal in the correct window, so in the correct path and on the master branch. Next thing we're going to do is go ahead and add our remote origin. So git remote add origin, and we're going to paste the name of the URL. And by the way, if you're using git bash to do this, it's shift and then insert to paste something. So we're going to click enter, and there you go. The remote origin has been added. So next thing we want to do is go ahead and learn about pushing and pulling. So we have all of this data here, and we're going to go ahead and push it onto our repository. So first thing you want to do is go ahead and make sure you're on the right branch, your master branch, or whatever branch you're going to use. You're going to click on push. And now you can see here it says push to repository origin. So through the terminal, we actually created and initiated that push-pull cycle and created the origin that we need. There we go. So then it says branches to push here. So we're just going to push the master branch. It's the only branch we're going to push. And of course, you're going to push it to which branch, which is going to be the remote master branch. And of course, you can track it or remember it, so we don't have to do it in the future. But again, we're not going to be using the terminal, so it doesn't really matter if you leave this on or not. So then we're going to go ahead and push it. This may take a while depending on the size of your project. Of course, you're going to need to log in there. So I'm just going to log in. And notice how all of this is very similar to the process we use in the terminal, except this time it brings up a nice little window for us to use. So we're just going to wait for that to push. And like I said, depending on the size of your project, this could take a few minutes to even a few hours. So just know that. So there you go. We pushed it onto our repository. Now you can see here we have two branches, master and origin/master. So just know that the origin / basically stands for any remote branches that you have. So this could be origin/error01 or origin/dev, depending on whatever remote branches you have currently initiated. So let's go ahead and check out our GitHub repository. Let's go and see how that's looking. So you can see right there we have 6 commits, 1 branch. So there we go. Everything is working. So the next thing I want to do is go ahead and add a README and a license through here. So first thing I want to do is add a README. And remember, we usually add readmes through GitHub. It just offers a really nice way to interact with it. So I'm going to go ahead and add that readme and commit it. Of course, just as usual, added readme. And we're going to commit directly to the master branch. Go ahead and commit that. So there we go, 7 commits. Now we're going to go and create a license. So I'm going to go and create a new file. Just as we've done in the past, there's nothing different here. License.md, and make sure it's in all caps. Then I'm going to choose the license template and choose the MIT license. So of course I'm just going to replace my credentials, review and submit, and there you go. Everything is working. Just going to finally commit it. Added license. There we go. So now we have created our README and our license. So what about pulling into our project here? What do we have to do? Well, it's pretty much the exact same thing. Right next to the push button is a pull button. You're just going to click on this, and now you can see here pull from remote origin, which is what we're looking for. And then it says the remote branch to pull, which is going to be our master branch. And like I said, depending on the branch that you're using, this could vary depending if you're on the development branch, maybe an error fixing branch. But usually you would push these changes after you've resolved them. So we're just going to go with the master branch for now. Now you have a few options here. So commit merge changes immediately, which is what we want to do. Include messages from commits being merged in merge commit. We're going to keep that off. And create a new commit even if fast forward is possible. Now basically we're not going to create a new commit because fast forwarding just allows us to push it all together, we know, without having to create a new commit. So just know that. Rebase instead of merge. Pretty much what's going on here is it's a little technique that a lot of developers use when pushing and pulling. I'm not going to go into rebasing now, but pretty much you're just going to want to keep this off. You don't really need to use it most of the time, except for in some cases, but usually that doesn't happen. So we're going to leave all 3 of these off. Next thing I want to do is go ahead and click OK, and it's going to pull everything from our top repository on GitHub into our local repository. And there you go. You can see that it's doing the exact same thing. These 2 new commits that we did on GitHub are now here. So that's pretty much it for push, and pull requests. Now you can see everything is almost exactly the same. We've run through all of this quite quickly, and just as I said in the past, most of this is the same process. It's just conveyed to us in a different way. So there we go. That's pretty much it for SourceTree. I hope you learned a little bit from this section. It's just, again, an alternate way to use Git and GitHub. Something, a lot of people, prefer GUIs over a terminal. So that's just something that, is a personal opinion. But whatever. Now you have 2 different ways of using Git and GitHub, and depending on your preferences, you can use it. It's always good to learn more. All right, let's move on to the next section. In this video, I am going to be going over a little bit more advanced feature in Git, and so I'm going to be talking about Git rebase. So this ties into Git merge when you merge branches into another branch, so you can combine the features, but there are some key differences and some main places that you should use both of them, and they both have their pros and cons. So first of all, let's actually talk about merging because it's really tied into it. So what happens when you merge a feature branch, for example, into your master? Well, pretty much what you're going to do is create a new commit that has all of the changes of both. So it kind of combines them and then stores it under one new commit. So that's what's going to happen. Now you can do the exact same thing, but with rebase, it's a little bit different because instead of creating one new commit that combines all of the features of the branch together, it instead moves each separate commit onto the tip of the branch that you're trying to move it onto. Hence the name rebase. You're moving everything onto a new branch. Now, one thing to keep in mind when you're rebasing is that it's not actually moving the commits. It's actually creating brand new commits. Even if they're exactly the same, basically what it's doing behind the scenes is not just moving them, it's actually sort of duplicating them with a different ID, so they're all different commits. So let's actually get started. Now I have a little place set up here where I can check out these files. So if I go into my Git log, you can see that I have our master branch, so some fake commits here, and then we have our hotfix. So let's say that maybe a bug was introduced into our system here and we need to fix it. So what I did is create this hotfix branch. Now there are some main places that you might want to use Rebase. The first place is when maybe your master branch, or if you're working on a branch with or a repository with multiple developers, your branches or your repositories don't really match up. So for example, you created a branch based off of the latest commit on a master branch, but then after that, a lot of maybe some other developers on your team have also added new features to the master branch. So now you're kind of behind and you don't really know what to do because more commits have been created, and if you merge them, it's going to cause a couple of conflicts and errors. So what we can do with this is actually, instead of merging the branches, we can use Rebase to move a branch onto the tip or the head of another branch, in this case the master. So in this case it won't really demonstrate it since we don't really have any new commits to add here, but pretty much what's going to happen is if we added another commit to our master branch, what's pretty much going to happen is this hotfix is going to be a little bit lagging behind. So what we can do is use the Git Rebase feature to actually move it up. So I'll just demonstrate it for you here, although you won't be able to see a difference. So the first thing we're going to do is go ahead and Git Checkout hotfix. So this is going to be the branch that we're on, and of course you can see that I'm already on it. Now let's say that in this time another developer on our team has created a brand new commit on our master branch. Maybe they added a brand new feature or a new config file, whatever it is, we need to fix this ASAP. So what we're going to be doing is using the Rebase feature to move it up to the latest commit on the master branch. So here's what you're going to do. You're going to type out Git Rebase, and then you're going to type out the name of the branch that you want to rebase on. In this case, it's our master branch. So if I type out master here and click enter, it's going to do its magic. And there we go, it says current branch hotfix is up to date. Now if I go ahead and log it here, you can see that nothing has changed, obviously, since no commits have been added and everything stays the same. Now what if we wanted to use Rebase to merge two branches together? So instead of now just moving this hotfix branch up, we want to actually move our hotfix branch onto our master branch. So this is also very easy. All you have to do first is check out the branch that you want to merge in. In this case, it's going to be our master branch. And then what we're going to do is use the Rebase feature again. But what we're going to say is we're going to rebase and then type out the name of the branch that we want to merge in. So we're going to type out hotfix. Now it's going to do its magic again. And we're going to wait. And you can see first rewinding head to replay your work on top of it. And then fast forwarded master to hotfix. Now if I go ahead and check out the log, you can see that master and hotfix are both at the same position. So pretty much what's happened here is our master has been updated to match the latest commits on our hotfix branch. So now everything is in sync and working together. So from here, it's relatively easy. All you have to do is, of course, delete your branch and you should be good to go. So there we go. That's pretty much it for hotfix. It's pretty easy to, not hotfix, for Rebase. Now it's pretty easy to implement and use it, but once you get into the really complicated features, so using, maybe multiple branches, rebasing, it gets quite hard to use. And of course, you're going to have to choose your style. Just know that both of them have some of the same advantages and disadvantages that were mentioned in this video. And they all have, their different benefits, and they can be used in different situations. Now, of course, you can choose whichever one you want to use based on, the situation that you're in. I would recommend personally sticking with merge because I feel like it's much easier to grasp and is also just a lot easier to handle because Rebase it's a very subject specific, so you can only use it in certain situations. But there we go. That's pretty much it for Rebase. Now, the last thing I want to talk about is some of the disadvantages of Rebase because we only talked about the benefits and how to use it. Now, of course, we have our Rebase here and it's all working and we can move around commits very easily. But one of the main disadvantages of Rebase is if you're trying to, get rid of certain commits. So for example, right here we have a hotfix added. Now, of course, a hotfix is only a temporary fix, maybe in the case of an emergency. Now, we don't really want to keep this, do we? Because we're trying to hide this. So you can see that we already have a permanent fix here. Now, of course, what we're trying to do with Rebase is retain the commit history of our branch. But we don't really need to do that since we already have our permanent fix and it's all ready to go. So all we really need to do is merge the two and create a new state based off of our permanent fix. So this is a case where rebase wouldn't really make any sense, and it's kind of useless since we're trying to get rid of this hotfix and it's only supposed to be a temporary commit as a backup just in case things go wrong. So that's one of the disadvantages. There's a lot more, but I'm not really going to cover them because they go quite in depth into some of the very technical parts of Git, and it would take hours to explain everything. So just know that all of them have their certain place and they can all be used in different situations to a great benefit. All right, let's move on. If you're watching this, you have reached the end of the course. Congratulations. I hope you enjoyed the journey and learning everything there is to know about Git and GitHub. Hopefully you've learned a lot and many different skills that you can use in your daily life, in development or in maybe your personal life. So I hope you've learned a lot, and if you have any questions or maybe you're fuzzy on a topic, go ahead and ask me or message me personally and I'll be more than happy to help you. So now that you've reached the end of the course, I'd just like to say Git isn't the only source control that you can use, and it's definitely not the last development tool that you should learn. There's so much more to source control and version control than just Git, and all of these different source control software provide different opportunities and benefits, and they all have different variations in what they can do and what they're mostly used for. So I hope you continue your development journey learning all of these different development tools. Alright, thank you for taking the course, and goodbye.